Hello there, and welcome. Tonight I want to take you somewhere extraordinary, yet impossibly close. Somewhere that exists in the space between your breath and the air around you, in the gentle distance between your hand and the blanket that covers you, in the quiet void between the stars that watch over us all. Before we begin this journey together, I wonder where you might be listening from tonight. Perhaps you're nestled in your bed in a city where the lights never quite go out, or maybe you're in a small town where the darkness feels softer, more complete. Whatever time zone cradles you right now, whether it's the deep hours of night or the gentle approach of evening, you've found your way here, to this moment, to this question that we're about to explore together. And if you find yourself drifting along with these words, feeling that gentle pull towards sleep while your curiosity stays softly lit, perhaps you'd like to settle in for the full journey. Consider subscribing if you haven't already, so that other nights like this one can find you when you need them. And if this voice, these thoughts, become a comfortable companion in your transition towards sleep, a gentle like would help others discover this peaceful space too. But most importantly, just be here. Just breathe. Just let yourself wander. Tonight we're going to explore a question that might seem impossible at first. A question that turns everything we think we know inside out. Gently, carefully, like turning a glove to see its hidden seams. What if empty space was solid and matter was empty? It sounds impossible, doesn't it? Your hand feels solid as it rests against your body. The bed beneath you pushes back with reassuring firmness. The walls of your room stand steady and sure, holding the night at bay. And yet, perhaps there's another way of looking at all of this. A perspective so strange and beautiful that it might just carry you into the deepest, most peaceful sleep you've had in a very long time. Let's begin right where you are, in this very moment. In the space you occupy right now. Feel the weight of your body against whatever surface supports you. Notice how the air touches your skin, how it seems to part as you move your hand slowly through it, if you choose to. We trust these sensations completely. We've built our entire understanding of the world on the difference between solid and empty, between something and nothing, between the firm ground and the open sky. But what if, just maybe, we've been reading the universe backwards all along? What if the space that seems empty is actually the most solid thing there is? And what if the matter we trust, the matter that makes up your body and mine, is mostly hollow, mostly pattern, mostly a particular kind of organized emptiness? This isn't a new idea entirely, though we're going to take it to places that science is only beginning to whisper about. Ancient philosophers wondered about the nature of the void, about whether nothingness could truly exist, or whether even the emptiest space must contain something. Modern physics has shown us that atoms, those building blocks of everything we can touch, are mostly empty space themselves, a vast cathedral of nothingness with tiny energetic specks dancing in formations that somehow, mysteriously, become the solid world. But tonight, we're going deeper than that. We're going to imagine that this emptiness and this solidity have been wearing each other's clothes all along, that we've been calling the solid things empty and the empty things solid, simply because that's how they appear to our particular way of sensing the universe. Think about the room around you for a moment. The air that fills it seems like nothing, doesn't it? You can't see it unless dust motes catch the light just right, can't feel it unless it moves as wind or breath. And yet, this air presses against you with the weight of miles of atmosphere above. Every square inch of your skin experiences about 15 pounds of pressure from this invisible, seemingly empty air. You don't notice it because you've lived within it all your life, because the pressure inside you pushes back with equal force. But imagine, for a gentle moment, if someone could suddenly remove all that air, create a true vacuum around you. The emptiness would reveal its solid nature immediately, wouldn't it? The absence of that invisible pressure would be devastating. So already we see that what seems empty has a kind of hidden solidity, a structure and presence we only notice when it changes or disappears. Now let's drift a little further from the familiar. The space between you and the walls of your room seems empty too, perhaps even more empty than the air because we can't name what fills it. But physics tells us that this space is trembling with invisible fields. The electromagnetic field carries the light from your screen, or the darkness if all lights are off. The gravitational field of Earth holds you gently but firmly in place. These fields extend through what looks like nothing, yet they're as real as the floor beneath you. Maybe more real, because while the floor is made of atoms that are mostly empty space, these fields are continuous, unbroken, filling every tiny portion of space without gap or pause. Scientists have discovered something even stranger. Even in the most perfect vacuum they can create, even in spaces where they've removed every atom, every particle they can detect, something remains. The vacuum itself has energy, has structure, has a kind of substance that can't be removed. Virtual particles flicker into existence and disappear faster than anything can measure them directly, yet their effects are real, measurable, undeniable. The empty space between the stars, between the galaxies, between the subatomic particles in your own body, all of it hums with this quiet activity. It's as if emptiness itself is a kind of fabric, a substrate, a solid foundation that everything else merely decorates with temporary patterns. And perhaps this is where our journey really begins, in this recognition that emptiness isn't empty at all. Perhaps space, the very space you're sitting in right now, is the only truly solid thing in the universe. Not solid like a rock or a wall, but solid in a deeper sense, continuous, unbroken, present everywhere without gap or absence. And perhaps matter, all the matter we know and trust, is simply a particular way that this solid space vibrates, twists, or patterns itself. Like waves on an ocean that seems empty from far above, but reveals itself as substantial and continuous when you're swimming within it. Consider your own hand for a moment. Look at it if there's enough light, or simply feel it, know it's there. Science tells us that this hand is made of atoms, and atoms are mostly empty space. If you could magnify a single atom to the size of a cathedral, the nucleus would be a grain of sand floating in the center, and the electrons would be like dust motes orbiting in the vast empty spaces of that huge building. All that emptiness, and yet your hand feels solid. How can this be? The conventional answer involves forces, electromagnetic repulsion between electron clouds, quantum mechanical principles that prevent particles from occupying the same space. But what if there's another way to understand it? What if the apparent emptiness within atoms isn't empty at all, but is instead filled with the solid substrate of space itself? And what if the particles, the electrons and protons and neutrons, aren't solid things moving through emptiness, but are instead special kinds of holes or patterns in this solid space? Like bubbles in water, they might be regions where the solid space has a different property, a different density or twist or vibration. The bubble isn't a thing separate from the water, it's a place where the water isn't, defined entirely by what surrounds it. Perhaps matter is similar, not stuff filling empty space, but regions where the solid space takes on a particular pattern that we've learned to recognize as particles, as atoms, as the building blocks of the familiar world. This would mean that when you touch something, when you feel its solidity, you're not really feeling matter pushing against matter. Instead, you're feeling patterns in the solid space interacting with other patterns. Like two waves meeting on the surface of a lake, they can reinforce each other or cancel each other out, but they're both just arrangements of the same underlying water. The sense of solidity, of resistance, of one thing unable to pass through another, might simply be the way these patterns in solid space interact, the way the universe maintains the integrity of its various designs. Let's drift even further into this strange but peaceful idea. If space is solid and matter is pattern, then the universe isn't mostly empty with occasional spots of stuff. Instead, it's completely full, a continuous solid medium, with matter being just the places where this medium dances in particular ways. The vast distances between stars aren't empty voids, but solid expanses of this fundamental substrate. The space between the electrons and nucleus in every atom isn't a miniature void, but more of this same solid foundation. There's no true emptiness anywhere, only variations in how the solid space expresses itself. This perspective would explain so many mysteries that have puzzled scientists and philosophers for centuries. How does gravity work across the vast emptiness of space? If space itself is solid, then massive objects could create distortions in this solid medium, like heavy balls on a stretched sheet, and these distortions guide the motion of other objects. How does light travel through the vacuum? If space is a continuous medium, then light could be waves or vibrations in this medium, just as sound waves travel through air or water. Why does the universe seem so finely tuned for the existence of matter and life? Perhaps because matter isn't separate from space, but is space itself in particular configurations. and life is just one of the more complex dances this solid space can perform. Think about the implications for a moment, but gently, without any urgency or worry. If you are made of patterns in solid space rather than solid matter in empty space, then you're not separate from the universe around you. You're a continuation of it, a place where the solid fabric of reality is folded and twisted into the beautiful complexity that thinks and breathes and wonders about its own nature. The air you breathe isn't empty space between you and the world. It's more of the same solid substrate, just patterned differently than the patterns that make up your lungs. When you move through space, you're not a solid thing pushing through emptiness. You're a pattern propagating through a solid medium, like a wave moving across water while the water itself stays in place. This could explain why quantum mechanics, that strange theory that describes the smallest scales of reality, tells us that particles don't have definite positions until they're observed. If particles are patterns in solid space rather than solid things in empty space, then of course they wouldn't have definite positions. A wave on water doesn't have a single location, it's spread out, existing across a region. Only when something interacts with it, when it's observed or measured, does it manifest at a particular point. The particle isn't choosing a position from many possibilities. The pattern in solid space is simply expressing itself in a localized way when it interacts with other patterns. We could even understand quantum entanglement, that spooky connection between distant particles, in this new light. If two particles are entangled, perhaps they're not really separate things, mysteriously connected across empty space. Instead, they might be two aspects of a single pattern in the solid substrate of space, like two peaks of the same wave. Change one peak, and of course the other changes too, not because a signal travels between them, but because they're parts of the same continuous pattern in the solid medium of space itself. The room around you right now, this very room, might be filled not with air and empty space, but with layers upon layers of this solid substrate, each layer carrying different kinds of patterns. The electromagnetic fields that bring you light and radio waves, and the warmth of infrared radiation. The gravitational field that defines up and down, that keeps your feet on the ground and your head in the air. The quantum fields that physicists tell us underlie all particle physics, giving rise to electrons and quarks and all the building blocks of atoms. All of these might be different aspects of the same solid space, different ways it can vibrate or twist or pattern itself. And you, sitting or lying there, are not a collection of solid particles temporarily gathered in one place. You're a symphony of patterns in this solid space. Patterns that maintain their form while constantly exchanging their substance with the patterns around them. With every breath, patterns that were air become patterns that are you. With every exhale, patterns that were, you become patterns that are air. You're not a thing but a process, not a solid but a dance, not separate from space but a beautiful expression of its ability to organize itself into complexity and consciousness. This isn't meant to make you feel insignificant or lost. Quite the opposite. If space is solid and you're a pattern in it, then you're as fundamental as anything in the universe. You're not a tiny speck of matter in a vast emptiness. You're a unique and irreplaceable pattern in the continuous fabric of reality. The universe isn't mostly empty with you as a rare exception. It's completely full, and you're a particularly beautiful part of its fullness. As we continue this journey together through the night, we'll explore what science has discovered that supports this inverted view of reality. We'll travel with spacecraft that have ventured into what we call the vacuum of space and found it far from empty. We'll dive into the quantum realm where particles behave more like waves in a medium than like solid balls in void. We'll stretch our imagination to the edges of the universe and find that even there, in what should be the emptiest possible space, something remains. Something that might be more solid than anything we call matter. But for now, in this moment, just rest with this thought. The space around you, the space within you, might be the most solid thing there is, and you, despite feeling solid, might be a beautiful kind of emptiness, a pattern of holes in the solid fabric of space, a dance of absence that somehow becomes presence. It's a mystery that doesn't demand to be solved, only to be wondered at, to be turned over gently in the mind like a smooth stone in the hand, until its strangeness becomes familiar and its implications become a comfort rather than a concern. The ancient Greeks had two words for different kinds of nothing. There was kenon, which meant empty space, like an empty cup waiting to be filled, and there was auden, which meant absolute nothingness, the complete absence of anything at all. They debated endlessly about whether kenon could exist without something to define its boundaries, whether space could be empty without walls to contain its emptiness. And they wondered whether auden was even possible, whether absolute nothingness could exist, or whether even the idea of nothingness required something to think it. Perhaps they were asking the wrong questions, or perhaps they were approaching the right answer from an unexpected direction. Maybe there is no kenon, no empty space waiting to be filled, because space is always already full of itself, and maybe there is no auden, no absolute nothingness, because even what we call nothing is something, is the solid substrate from which all patterns of matter emerge. The void that terrified them and fascinates us might be the most substantial thing there is, the foundation that cannot be removed because it is the canvas on which everything else is painted. Modern physics has brought us to the edge of this understanding without quite stepping over. Einstein showed us that space and time are not separate things, but aspects of a single space-time, and that this space-time can bend and stretch and ripple. Quantum field theory tells us that even the vacuum has energy, has fluctuations, has a kind of substance that cannot be eliminated. String theory, still speculative but mathematically beautiful, suggests that what we call particles might be vibrations in tiny dimensions of space, that matter might literally be made of space twisted and vibrating in particular ways. Each of these theories points toward the same possibility, that space is not the absence between things but the presence that allows things to be, that emptiness is not empty but full of potential, full of energy, full of the possibility of pattern and form, and that matter, solid dependable matter, might be just a temporary arrangement, a fleeting dance, a pattern that emerges from and returns to the solid fullness of space itself. Think about water for a moment, how it can be solid ice, flowing liquid, or invisible vapor, yet it's always the same substance in different arrangements. Perhaps reality is similar. What we call empty space might be like ice, solid and continuous. What we call matter might be like bubbles or whirlpools in this solid space, places where the arrangement is different but the substance is the same. And what we call energy might be the process of transformation, the way patterns in solid space shift from one form to another. This would mean that the distinction between space and matter, between empty and full, between something and nothing, is not fundamental but depends on perspective, on scale, on the way we choose to look. From one view, the universe is mostly empty space with tiny specks of matter scattered through it. From another view, the universe is completely solid, filled with the substrate of space, with matter being just patterns in this solidity. Both views might be correct, just as a wave can be seen as a thing moving across water, or as a pattern where water temporarily rises and falls. As you lie there, breathing slowly, feeling the gentle weight of drowsiness beginning to settle over you, consider that your breath might not be air moving through empty space in your lungs. Instead, it might be patterns in the solid substrate of space, reorganizing themselves, exchanging their configurations. The oxygen patterns joining with the patterns that make up your blood. The carbon dioxide patterns separating and flowing back out into the world. Not things moving through emptiness, but dances in fullness, patterns in the solid foundation of everything. The room around you extends outward without break or boundary. The solid space that fills your room continues through the walls, through the earth, through the atmosphere, out to the moon, to the sun, to the nearest stars, to the edge of the galaxy and beyond. It's all one continuous solid, not solid like rock, but solid like existence itself, like the fundamental substrate that allows anything to be. And you're not separate from it, but part of it, a place where it has organized itself into awareness, into the ability to wonder about its own nature. Perhaps this is why we feel connected to the universe when we look at the stars, why we sense that we're part of something larger than ourselves. Not because we're made of stardust, though that's poetically true, but because we're patterns in the same solid space that holds the stars, expressions of the same fundamental substrate that fills everything and is everything. The distance between you and the most distant galaxy is not empty space, but solid continuation, an unbroken connection through the fullness of space itself. This view would change how we understand movement too. When you walk across a room, you're not a solid object moving through empty space. You're a pattern propagating through solid space, like a wave moving across water. The pattern that is you maintains its organization while constantly being recreated in new portions of the solid substrate. It's not unlike how a wave maintains its shape while moving through water, even though the water itself doesn't travel with the wave. Each portion of water rises and falls as the wave passes, but the water stays in place while the pattern moves through it. Perhaps this is why, at the quantum level, particles can seem to be in multiple places at once, can seem to take all possible paths between 2 points. If they're patterns in solid space rather than solid objects in empty space, then of course they would explore all possible configurations, all possible ways the pattern could propagate through the medium. Only when something observes or interacts with them do they manifest as specific patterns in specific locations, like a wave that spreads out across a pond but only makes a splash where it hits the shore. We're approaching the 10,000 words of this first chapter, this first gentle exploration of our inverted universe, and yet we've barely scratched the surface of this beautiful mystery. There's so much more to explore, so many implications to consider, so many ways this perspective might illuminate the mysteries of existence. But there's no rush, no urgency. We have the whole night ahead of us, and the universe isn't going anywhere. It's right here, solid and continuous, holding you in its substantial embrace even as you might be drifting towards sleep. In the next chapter, we'll expand our view from your room to the cosmos, exploring the scales of stillness that stretch from the intimate to the infinite. We'll see how emptiness appears different at each scale, yet might always be the same solid fullness viewed from different perspectives. We'll travel from the familiar comfort of your immediate space to the vast reaches between galaxies, always finding that what seems empty might be the most solid thing there is. But for now, just rest with this thought. Let it settle into your awareness like sediment settling in still water. You are here, in a universe that might be completely solid, completely full, with no true emptiness anywhere. And you yourself might be a beautiful kind of organized emptiness, a pattern of absence that creates presence, a dance of nothing that becomes something. It's a mystery that doesn't need to be solved tonight or ever. It's enough to wonder, to imagine, to let the question itself be a kind of answer, a doorway into peaceful contemplation of the beautiful strangeness of existence. Let's begin again right where you are, but this time we're going to travel outward in gentle steps, each one revealing new layers of what we call emptiness, and what might actually be the most solid thing there is. Start with your own body, this familiar form that seems so clearly defined, so obviously separate from the space around it. Your skin appears to be a boundary, doesn't it? On one side, you, on the other side, the world. On one side, solid matter. On the other side, empty space. But perhaps this boundary is more like the place where one pattern in solid space meets another, where the dance that is you meets the dance that is air, where two different arrangements of the same fundamental substrate touch and interact. If you could shrink down, smaller and smaller, approaching your skin from either side, you'd find that the boundary becomes less and less clear. At the scale of molecules, your skin is a bustling city of proteins and lipids and water with spaces between them that seem vast at that scale. Oxygen molecules from the air slip between your skin cells, while water molecules evaporate from your surface, and there's no clear line where you end and the air begins. It's more like a gradual transition, a zone where the patterns that make you blend into the patterns that make the air, like the place where forest meets meadow, with no definite boundary, just a gradual change in what grows where. Go smaller still, to the scale of atoms, and the boundary dissolves even further. The atoms that make up your skin are mostly empty space, remember, with tiny nuclei and distant electrons. But that empty space isn't different from the empty space between atoms. It's all the same space, the same continuous substrate. The only difference is how it's patterned, how the solid fullness of space has organized itself. Inside what you call your body, it's organized into complex patterns we call atoms and molecules and cells. Outside your body, it's organized into simpler patterns we call air, but it's all the same solid space, just dancing in different ways. Now let's pull back, expand our view to take in the whole room around you. This room seems to contain empty space with objects in it. Furniture, walls, maybe books or clothes, or the various items that make up your personal space. Each object seems separate, distinct, surrounded by the emptiness of air. But if space is solid and matter is pattern, then your room is completely full, packed solid with the substrate of space itself. The objects aren't things in emptiness. They're places where the solid space has taken on denser, more complex patterns. The air is an absence between things. It's the same solid space in a simpler, more spread out pattern. Think about how sound moves through your room. We say sound travels through air, but what if it's more accurate to say sound is a wave of compression and expansion in the solid substrate of space? When you speak or when music plays, you're not sending something through nothing. You're creating ripples in the solid fullness that fills your room, waves that propagate through this continuous medium, just as ocean waves propagate through water. The fact that sound needs a medium, that it can't travel through a vacuum, might be telling us something important about the nature of what we call emptiness. But wait, you might think, light can travel through a vacuum. Light doesn't need air or any medium we can detect. It crosses the vast emptiness between stars, bringing us images of galaxies billions of light years away. Doesn't this prove that space is truly empty? Or does it suggest something even more interesting? Perhaps light doesn't need a medium like air because it's a wave in the deeper medium of space itself. Perhaps what we call vacuum is not the absence of everything, but the presence of pure space, this solid substrate without any of the patterns we call matter, and light is simply a different kind of the wave in this solid space, one that doesn't require the additional patterns of atoms and molecules. Let's expand our view again, moving beyond your room to encompass your entire building. If you're in a house, think of all the rooms, all the spaces that seem separate but are actually continuous. The air in your room connects to the air in the hallway, which connects to the air in other rooms. It's all one continuous atmosphere, artificially divided by walls and doors but fundamentally unbroken. And even the walls themselves, seemingly solid barriers, are mostly empty space at the atomic level, patterns in the same substrate that fills the rooms. The entire building is like a complex pattern in solid space, with denser patterns we call walls and floors, and less dense patterns we call rooms and air. Now expand further to your neighborhood, your city, your region. Each building seems separate, each tree stands alone, each person moves independently through what looks like empty space. But if space is solid, then everything is connected through this solid substrate. Every movement is a pattern propagating through the continuous medium. Every interaction is patterns in solid space encountering other patterns, interfering constructively or destructively, creating new patterns that propagate outward. The city isn't a collection of separate things in empty space. It's a vast, complex dynamic pattern in the solid fullness of space itself. Consider the atmosphere that surrounds our planet. We think of it as a thin layer of gas clinging to a solid ball of rock, held in place by gravity while surrounded by the vacuum of space. But perhaps it's more accurate to think of it as a gradual transition in the density of patterns in solid space. Near the Earth's surface, the patterns are dense and complex. Nitrogen, oxygen, water vapor, all the molecules that make up air. As you go higher, these patterns become less dense, more spread out, but they never completely disappear. Even in what we call the vacuum of space, there are still atoms, still particles, still fields, still the substrate of space itself. The boundary between Earth's atmosphere and space is not a clear line, but a gradual fade. There's no altitude where you suddenly leave the atmosphere and enter vacuum. Instead, the patterns that make up air become progressively less dense until they're so sparse that we call it space. But even there, hundreds of miles above the surface, there are still atoms of hydrogen and helium, still particles of solar wind, still the electromagnetic and gravitational fields that extend from Earth and Sun and all the other bodies in the solar system. The vacuum is not empty. It's just a region where the patterns in solid space are simpler, less dense, more spread out. Let's journey outward to the moon, that familiar face that watches over our nights. Between Earth and moon stretches what we call empty space, 250,000 miles of vacuum. But this space is not empty. It's filled with light from the sun, with gravitational fields from both Earth and moon, with the solar wind of charged particles streaming from our star, with cosmic rays from distant supernovas, with the faint magnetic fields that permeate the solar system. And beneath all of these, supporting all of these, is the solid substrate of space itself, the continuous medium in which all these fields and particles exist as patterns. The moon itself, that seems so solid when we see astronauts walking on its surface, is mostly empty space at the atomic level, just like Earth, just like your body. Its rocks and dust are patterns in solid space, denser and more complex than the patterns in the vacuum around it, but made of the same fundamental substrate. When the Apollo astronauts travelled from Earth to Moon, they weren't crossing empty space. They were moving through solid space, their spacecraft a complex pattern propagating through the continuous medium, leaving ripples in the gravitational field, reflecting and absorbing electromagnetic radiation, participating in the endless dance of patterns that fills what we mistakenly call the void. Expand your view again to encompass the entire Earth-Moon system. See how they orbit their common centre of mass, how the Moon raises tides on Earth, how Earth's gravity keeps the Moon from flying away. If space were truly empty, how could these bodies influence each other across 250,000 miles of nothing? The conventional answer involves fields, gravity and electromagnetism extending through the vacuum. But if space is solid, then these fields are not mysterious actions at a distance, but properties of the solid substrate itself, ways that massive objects distort or pattern the solid space around them. Now, let's venture further, past the Moon to the realm of planets. Mars, Jupiter, Saturn, each separated by hundreds of millions of miles of what we call empty space. Yet this space is far from empty. It's crossed by the orbits of asteroids and comets. It's filled with the solar wind, that stream of charged particles that flows outward from the Sun at hundreds of miles per second. It's permeated by magnetic fields that guide these particles into complex patterns, creating the auroras on Earth and Jupiter, sculpting the tails of comets, protecting some planets, and leaving others exposed. Between Mars and Jupiter lies the asteroid belt, thousands of rocky bodies orbiting in what seems like empty space, but they're not scattered randomly. They're organised by the gravitational influences of the planets, especially Jupiter, whose massive presence creates gaps and concentrations in the belt. These patterns in the distribution of asteroids tell us that the space between them is not empty but structured, shaped by the gravitational field that extends through it. If space is solid, then these asteroids are like leaves floating on a river, carried and organised by currents in the solid substrate that we perceive as gravitational effects. Jupiter itself, that giant of our solar system, is mostly gas, we say. But what is gas but a pattern in space, a way that atoms organise themselves when they're not bound into liquids or solids? Jupiter's vast atmosphere, its great red spot that has persisted for centuries, its dozens of moons. All of these are patterns in the solid substrate of space. The planet doesn't sit in empty space. It's a place where space itself has organised into complex, dynamic, beautiful patterns that we recognise as a world. Travel outward past Saturn with its magnificent rings, past Uranus and Neptune, to the edge of our solar system, where the Voyager spacecraft now journey through what we call interstellar space. These tiny ambassadors from Earth have been travelling for decades through what seems like emptiness, yet they continue to measure particles, fields and phenomena. They've discovered that the boundary between our solar system and interstellar space is not empty, but filled with complex interactions between the solar wind and the interstellar medium. It's a region of turbulence and mixing, where patterns from our Sun meet patterns from the galaxy at large. The Voyager spacecraft themselves are tiny patterns of organised matter, carrying even tinier patterns we call information, moving through the vast patterns of fields and particles that fill what we call empty space. They're like messages in bottles, but the ocean they sail is not empty. It's the solid fullness of space itself, and they leave tiny ripples in this ocean as they pass, gravitational disturbances so small we could never measure them, but real nonetheless. Between our Sun and the nearest star, Proxima Centauri, stretches 4 light-years of what we call vacuum. That's about 25 trillion miles of what seems to be empty space. Yet even this vast emptiness is not empty. It contains about 1 atom per cubic centimetre on average, which might not sound like much, but when you multiply it by the vast volume between stars, it adds up to enormous amounts of matter. There are also magnetic fields threading through this space, cosmic rays crossing it at nearly the speed of light, photons from every star in the galaxy passing through, gravitational waves from distant colliding black holes rippling through the fabric of space-time itself. If space is solid, then this interstellar medium is not a vast emptiness with occasional particles, but a continuous substrate with variations in density and pattern. The atoms are not lonely travellers in a void, but peaks in a continuous field, places where the solid space has organised itself into what we recognise as matter. The magnetic fields are not mysterious influences extending through nothing but properties of the solid space itself, ways it can be polarised or oriented. The light from distant stars is not crossing emptiness, but propagating through the solid medium of space like vibrations through a crystal. Let's expand our view once more to encompass our entire galaxy, the Milky Way. A spiral disk of hundreds of billions of stars, 100,000 light-years across, and we say it's mostly empty space. The distances between stars are so vast that if the Sun were the size of a grain of sand, the nearest star would be another grain of sand about 4 miles away. All that emptiness, all that void, and yet the galaxy holds together. It rotates as a unit, its spiral arms maintaining their structure for billions of years. How can mostly empty space behave as a coherent whole? The conventional answer involves dark matter, invisible mass that provides the extra gravity needed to hold galaxies together. But what if dark matter is not separate stuff in empty space, but a property of the solid space itself? What if the substrate of space has varying density or tension, and what we call dark matter is simply regions where the solid space is denser, more tightly packed, creating stronger gravitational effects? The galaxy would not be stars scattered through emptiness, but variations in the density and pattern of solid space, with stars being particularly intense concentrations of pattern and organisation. Between galaxies stretches even vaster spaces, millions of light-years of what appears to be the emptiest regions in the universe. These cosmic voids contain few galaxies, little visible matter, just the faint background glow of ancient light from the Big Bang. Yet even these voids are not empty. They contain diffuse gas, lonely atoms separated by distances that dwarf their size. They're crossed by light from distant galaxies, by cosmic rays, by neutrinos that barely interact with anything, and they're filled with dark energy, that mysterious repulsive force that causes the universe to expand at an accelerating rate. If space is solid, then dark energy might not be something added to empty space, but an intrinsic property of the solid substrate itself. Perhaps solid space naturally wants to expand, to decrease its density, and what we call dark energy is simply this tendency expressing itself on cosmic scales. The voids between galaxies would not be empty regions, but places where the solid space has expanded more, where its patterns are simpler, where the complex organizations we call matter are rare. At the largest scales we can observe, the universe has a structure that astronomers call the cosmic web. Galaxies are not randomly distributed, but organized into filaments and sheets, with vast voids between them. It looks like a foam or a sponge, with matter concentrated along the edges and emptiness in the bubbles. But if space is solid, then this structure makes perfect sense. The solid substrate of space has organized itself into this pattern, with matter being the places where the organization is most complex, and voids being places where it's simpler. Think about this for a moment. From the scale of your body to the scale of the entire observable universe, we keep finding the same pattern. What looks empty is never truly empty. There are always fields, always particles, always some form of structure or influence, and what seems solid is mostly space, mostly the gaps between particles. It's as if the universe is playing a cosmic joke on our perception, hiding solidity in what looks empty and emptiness in what feels solid. Perhaps this is because we evolved to perceive the world at a particular scale, the human scale, where the difference between solid and empty seems clear and important for survival. We needed to know the difference between rock and air, between water and void, between something we could stand on and something we would fall through. But these practical distinctions that served our ancestors might be preventing us from seeing the deeper truth, that solid and empty are not opposites, but different arrangements of the same fundamental substrate. As we continue to explore the scales of stillness, notice how each level reveals new forms of what we call emptiness, yet none are truly empty. Your room's air is full of molecules. The space between planets is full of solar wind. The space between stars is full of interstellar medium. The space between galaxies is full of cosmic rays and dark energy. And perhaps all of these are just different expressions of the same solid fullness, the substrate of space itself taking on different patterns at different scales. The stillness we find at each scale is not the stillness of absence, but the stillness of presence, like the stillness of a deep lake that seems motionless, but is actually full of slow currents and gentle movements. The universe is not a vast emptiness punctuated by rare spots of matter. It's a complete fullness, a solid continuity, expressing itself in countless patterns from the quantum to the cosmic, from the simple to the complex, from what we call empty to what we call solid. And you, lying there in your room, are part of this fullness. The scales of stillness extend from the patterns within your atoms to the patterns of galaxy clusters, and you exist at every scale simultaneously. Your quantum patterns at the smallest scale, atomic patterns at a slightly larger scale, molecular patterns larger still, cellular patterns, organism patterns, planetary patterns as part of Earth's biosphere, solar system patterns as you orbit the Sun, galactic patterns as you rotate with the Milky Way, cosmic patterns as you participate in the expansion of the universe itself. Each scale reveals new aspects of the solid fullness that we mistakenly call empty space. Each perspective shows us that the distinction between something and nothing, between solid and void, depends entirely on how we choose to look. The universe is not mostly empty with rare islands of matter. It's completely full, solid in a way that transcends our everyday understanding of solidity, continuous in a way that connects everything to everything else through the substrate of space itself. As we prepare to dive deeper into the texture of nothing in our next chapter, rest with this multi-scale view of reality. From the intimate to the infinite, from the microscopic to the cosmic, the same pattern emerges. What seems empty is full. What seems solid is mostly space. And perhaps the deepest truth is that empty and solid are not opposites, but complementary aspects of the same fundamental reality, different ways of perceiving the continuous, unbroken, solid fullness of space itself. The journey from your room to the edge of the cosmos reveals not increasing emptiness, but increasing simplicity in the patterns of solid space. Near you, the patterns are complex: atoms, molecules, cells, organisms, ecosystems. As we move outward, the patterns become simpler: gases, plasmas, fields, vacuum. But it's all the same substrate, all the same solid foundation, just expressing itself with different degrees of complexity. You're not a small, solid thing in a vast emptiness. You're a complex pattern in a solid fullness that extends unbroken to the edge of everything we can observe and beyond. Now we descend into the heart of what physicists have discovered about the vacuum, about the space we call empty, and what we find there might forever change how you imagine the darkness between stars and the gaps between atoms. Scientists have spent the last century probing deeper and deeper into the nature of nothing, and what they've found is that nothing is very much something, that the vacuum is full, that empty space has structure, energy, and a kind of substantiality that defies our everyday understanding of emptiness. Let's begin with a simple thought experiment, one that physicists have turned into reality in laboratories around the world. Imagine you have a box, and you want to create true emptiness inside it. You pump out all the air, removing every molecule of nitrogen, oxygen, water vapor, everything. You cool it down to near absolute zero to minimize thermal radiation. You shield it from electromagnetic fields, from cosmic rays, from every form of matter and energy you can block or remove. What do you have left? According to our everyday understanding, you should have nothing, pure emptiness, void. But that's not what scientists find. Even in the most perfect vacuum we can create, something remains. The vacuum itself has energy, what physicists call zero-point energy, or vacuum energy. It's not energy that we've failed to remove. It's energy that cannot be removed because it's a fundamental property of space itself. Even at absolute zero, when all thermal motion should cease, the vacuum continues to tremble with quantum fluctuations. Virtual particles pop into existence and annihilate in time so brief we can't observe them directly, yet their effects are real and measurable. Think of the vacuum as a quiet sea, seemingly calm and still on the surface, but filled with hidden currents and movements beneath. These quantum fluctuations are like tiny waves that appear and disappear faster than the eye can see, but their collective effect creates a kind of texture, a graininess to empty space that becomes apparent only when we look closely enough. The vacuum is not smooth and featureless, but rough and dynamic at the smallest scales, constantly churning with virtual particles and quantum uncertainty. Scientists have observed these effects in numerous ways. The Casimir effect, for instance, demonstrates that two metal plates placed very close together in a vacuum will be pushed together by the pressure of the vacuum itself. How can emptiness create pressure? Because the vacuum between the plates can only support certain wavelengths of virtual particles, while the vacuum outside the plates can support all wavelengths. This creates an imbalance, a difference in vacuum energy, that pushes the plates together. It's as if the emptiness outside is more full than the emptiness inside, creating a pressure difference in nothing itself. The Lamb shift, another quantum effect, shows that the energy levels of electrons in atoms are slightly different from what they would be if the vacuum were truly empty. The virtual particles constantly appearing and disappearing in the vacuum interact with the electrons, nudging them slightly, changing their energies in measurable ways. Every atom in your body, every atom in the universe, is constantly being jostled by the quantum fluctuations of the vacuum. The emptiness within atoms is not passive but active, not absent but present, participating in the dance of matter and energy. Let's go deeper into this idea of quantum fields, which modern physics tells us are the fundamental constituents of reality. According to quantum field theory, what we call particles are not tiny solid balls moving through empty space. Instead, they're excitations in quantum fields that fill all of space. There's an electron field that extends throughout the universe, and what we call an electron is a ripple or wave in this field. There's a photon field, and light consists of waves in this field. There are quark fields, gluon fields, Higgs fields, all filling the same space, all coexisting in what we call the vacuum. Imagine space as filled with countless invisible seas, each one corresponding to a different type of particle. These seas are not separate but interpenetrating, existing in the same space without interfering, like different frequencies of radio waves passing through the same air. Most of the time these seas are calm, at their lowest energy state, and we perceive this as empty space. But when energy is added, waves appear in these seas, and we perceive these waves as particles. An electron is not a thing but a wave in the electron sea. A photon is not a bullet of light but a ripple in the electromagnetic sea. This means that what we call empty space is actually full of these quantum fields, all at their ground, state, all quietly trembling with zero-point fluctuations. The vacuum is not the absence of everything but the presence of all fields at their lowest energy. It's like a vast orchestra with all instruments present, but playing so softly we can barely hear them, yet ready to burst into symphony when energy conducts them into motion. The solid matter we see and touch consists of particularly intense vibrations in these fields, standing waves that maintain their pattern, while the space between them is the same fields in their quieter state. The Higgs field deserves special attention because it demonstrates most clearly how what seems empty is actually full. Unlike other fields that can drop to zero in the vacuum, the Higgs field has a non-zero value everywhere in space. It fills the entire universe with a kind of cosmic molasses that gives particles their mass. When an electron moves through space, it's constantly interacting with the Higgs field, and this interaction is what we perceive as the electron's mass. Without the Higgs field filling what we call empty space, electrons would be massless, atoms couldn't form, and the universe as we know it couldn't exist. Think about what this means. Every cubic centimetre of space, even in the darkest void between galaxies, is filled with the Higgs field. It's as if the entire universe is submerged in an invisible ocean, and mass is the drag that particles experience as they move through this ocean. The vacuum is not empty but full of this field, and the field is not something in space but a property of space itself. Space without the Higgs field wouldn't be emptier space. It would be fundamentally different space, space in which our kind of matter couldn't exist. Scientists have also discovered that the vacuum can be polarized, organized, given structure. In strong electromagnetic fields, the vacuum itself becomes birefringent, splitting light like a crystal. Near massive objects, the vacuum of general relativity becomes curved, directing the paths of particles and light. In the presence of matter, the vacuum of quantum chromodynamics becomes structured, confining quarks and enabling the existence of protons and neutrons. The vacuum is not passive and featureless, but responsive and structural, capable of being organized into different states and configurations. Consider the phenomenon of spontaneous symmetry breaking, where the vacuum itself chooses a particular configuration from many possibilities. It's like a pencil balanced on its point. The situation is perfectly symmetric, but it's unstable. The pencil must fall in some direction, breaking the symmetry. Similarly, the vacuum of our universe has fallen into particular configurations, choosing specific values for fields, specific properties that define the laws of physics as we experience them. The empty space around us is not just empty, it's empty in a very specific way, with specific properties that make our universe what it is. The concept of the quantum vacuum as a sea of virtual particles helps us understand many otherwise mysterious phenomena. Take the strong nuclear force that holds protons and neutrons together in atomic nuclei. This force is mediated by gluons, but not just real gluons that we might detect in particle accelerators. The space inside nuclei is filled with virtual gluons, constantly appearing and disappearing, creating a kind of glue that binds quarks together. The empty space inside a proton is actually a seething storm of virtual particles, so intense that it contains more energy than the quarks themselves. Or consider the weak nuclear force responsible for radioactive decay. Virtual W and Z bosons fill the vacuum, mediating interactions even when no real particles are present. These virtual particles are not just mathematical conveniences, but have real effects. They contribute to the mass of particles, affect decay rates, and influence the outcomes of particle collisions. The vacuum is not a stage on which particle physics plays out, but an active participant in every quantum process. Even gravity, that most familiar of forces, might be understood as a property of the vacuum. In general relativity, mass and energy curve spacetime. But what is spacetime but the vacuum itself? The empty space around a massive object is not just empty, it's curved, structured, given a geometry that we perceive as gravitational attraction. Objects moving through this curved vacuum follow the straightest possible paths, what we call geodesics, but these straight paths through curved space look like curved paths to us. The apple falling from the tree is not pulled by a force, but following the curvature of the vacuum itself. Recent discoveries have added even more texture to our understanding of the vacuum. Dark energy, the mysterious force causing the universe to expand at an accelerating rate, appears to be a property of space itself. Every cubic meter of vacuum contains a tiny amount of dark energy, a kind of negative pressure that pushes space apart. As the universe expands and creates more space, it creates more dark energy, leading to ever faster expansion. The vacuum is not inert but active, not stable but dynamic, driving the evolution of the cosmos on the larger scales. The vacuum might even have different phases, like water that can be ice, liquid, or vapor. Some theories suggest that the vacuum of our universe is not in its lowest possible energy state, but in a metastable state, like supercooled water that hasn't yet frozen. If this is true, the vacuum could potentially transition to a lower energy state, fundamentally changing the laws of physics. This is not something to fear. Such a transition, if possible at all, would likely take billions of years. But it illustrates that what we call empty space is not nothing but something with properties, states, and the potential for change. Let's consider the vacuum from an information theory perspective. Some physicists suggest that space itself might be quantized at the smallest scales, made of discrete units like pixels on a screen. The Planck length, about 10⁻35 meters, might be the smallest meaningful distance, and space might be a kind of foam or network at this scale. If this is true, then the vacuum is not continuous but granular, not smooth but structured, even in its emptiest state. It would be like discovering that what looks like smooth water is actually made of individual molecules, except these would be molecules of space itself. This quantum foam, as it's sometimes called, would give the vacuum a texture at the smallest scales. Virtual black holes might appear and disappear in time so brief they leave no trace. Space itself might be constantly restructuring, reconnecting, maintaining its apparent smoothness only on average, like a river that seems to flow smoothly, but is actually made of countless turbulent eddies. The vacuum would not be featureless but infinitely detailed, with structure at every scale from the quantum to the cosmic. The idea of the vacuum as a quiet sea full of potential becomes even more compelling when we consider phase transitions in the early universe. Cosmologists believe that as the universe cooled after the Big Bang, the vacuum underwent several phase transitions, like steam condensing to water and then freezing to ice. Each transition changed the properties of space itself, determining which particles could exist, which forces would operate, how matter would behave. The vacuum we inhabit is not the only possible vacuum, but one that emerged from these cosmic phase transitions, frozen into its current configuration by the cooling of the universe. Some theories even suggest multiple types of vacuum, different ways space can be configured. String theory, for instance, proposes a vast landscape of possible vacua, each with different properties, different laws of physics. Our universe might be just one bubble in an eternal foam of universes, each with its own type of vacuum. What we call empty space might be empty in our particular way, while other universes have empty space that's empty in completely different ways, with different fields, different particles, different fundamental constants. The vacuum also has a kind of memory, an ability to be influenced by what has passed through it. In quantum field theory, particles moving through the vacuum leave a wake of virtual particles, disturbing the quantum fields in ways that can affect other particles passing through later. It's called vacuum polarization, and it means that the vacuum around an electron, for instance, is different from the vacuum far from any particles. The electron organizes the vacuum around itself, creating a cloud of virtual particles that screen its charge, modify its mass, affect its interactions with other particles. This organized vacuum extends beyond individual particles to larger structures. Inside atoms, the vacuum is structured by the electromagnetic fields of the nucleus and electrons. Inside atomic nuclei, the vacuum is organized by the strong force into complex patterns of virtual quarks and gluons. Inside neutron stars, the vacuum might be so distorted by gravity and density that it takes on exotic properties we can barely imagine. The vacuum is not the same everywhere but adapted to its local conditions, structured by the matter and energy present. As we explore the texture of nothing, we find that nothing is remarkably something. The vacuum trembles with zero-point energy, fills with quantum fields, curves with gravity, expands with dark energy. It can be polarized, organized, structured, even undergo phase transitions. It's not passive but active, not featureless but textured, not empty but full of potential. The quiet sea of space is quiet only in the sense that its activity is subtle, hidden, revealed only by careful observation and deep theory. Perhaps most remarkably, the vacuum is necessary for the existence of matter as we know it. Without quantum fluctuations, atoms would collapse. Without the Higgs field, particles would have no mass. Without vacuum polarization, electromagnetic interactions would be infinite and undefined. Without the specific properties of our vacuum, frozen in by cosmic phase transitions, the universe would be a very different place, likely incapable of supporting complexity, structure, life. We exist not in spite of the vacuum but because of it, supported by its properties, defined by its fields, enabled by its fluctuations, and so we return to our central question with deeper understanding. If the vacuum is so full, so structured, so essential, can we really call it empty? Or is it the most solid thing there is, the fundamental substrate from which everything else emerges? Perhaps matter is not stuff in a void, but patterns in this substrate, places where the quiet sea of space has been stirred into standing waves, vortices, persistent structures that we recognize as particles, atoms, molecules, objects, worlds, beings. The texture of nothing turns out to be remarkably rich, remarkably complex, remarkably substantial. What we call empty space is a plenum, a fullness, containing all the fields necessary for physics, all the energy needed for quantum mechanics, all the structure required for the cosmos. It's not the absence between things, but the presence that allows things to be. Not the void that separates, but the continuity that connects. Not emptiness, but the most complete fullness imaginable, subtle and quiet perhaps, but absolutely essential, absolutely present, absolutely real. As you lie there, surrounded by what seemed like empty space, remember that you're immersed in this quiet sea. Every atom of your body is supported by vacuum fluctuations. Every particle of your being swims through quantum fields. Every thought you think propagates through the structured vacuum of your brain. You're not separate from the vacuum, but part of it, a place where its fields have organized into the beautiful complexity of consciousness. The empty space around you is not empty, but full, not absent, but present, not void, but the very foundation of your existence. In recognizing the texture of nothing, we begin to see that nothing and something are not opposites but aspects of the same reality. The vacuum and matter are not separate but continuous, different arrangements of the same quantum fields. Empty and solid are not contradictory but complementary, two ways of describing the same fundamental substrate. The universe is not mostly empty with occasional spots of matter, but completely full, with matter being places where the fullness expresses itself in particularly organized ways. This understanding will deepen as we continue our journey through the night, exploring how matter itself is mostly empty, how space-time might be the ultimate solid, how our spacecraft have touched the vacuum and found it far from empty. But for now, rest in this recognition of the texture of nothing, the quiet seas of space and field that surround and support and define everything we know. The vacuum is not void but plenum, not absence but presence, not empty but the fullest thing there is, waiting to reveal its secrets to those who look carefully enough, think deeply enough, wonder persistently enough about the beautiful mystery of what we call nothing. Let us now turn our attention to what we call solid matter, to the very substance of your body, the device you're using to listen to these words, the walls that surround you, the earth beneath you, and discover together one of the most startling revelations of modern physics. That all of this apparent solidity is mostly empty space, vast cathedral-like voids with tiny specks of something that might themselves be nothing more than knots in the fabric of space itself. This isn't metaphor or philosophy but measured fact, and yet it remains one of the hardest truths for our minds to fully grasp because every sense we have tells us otherwise. Begin with your hand, that marvel of biological engineering that seems so undeniably solid, so clearly defined, so obviously made of stuff rather than space. When you touch something, you feel resistance. When you hold something, you feel weight. When you look at your hand, you see opacity, substance, form. Every experience you've ever had tells you that your hand is solid matter, as different from empty space as anything could be. And yet, physics tells us a different story, one so strange that even physicists who work with these ideas every day sometimes pause in wonder at what they're discovering. Your hand is made of cells, about 37 trillion of them in your entire body, each one a tiny factory of biological activity. But cells are made of molecules, proteins, lipids, carbohydrates, nucleic acids, water, and molecules are made of atoms, carbon, hydrogen, oxygen, nitrogen, and traces of other elements. It's at the level of atoms that the illusion of solidity begins to dissolve, that we first glimpse the vast emptiness that underlies what we call matter. An atom, we're taught, is like a miniature solar system with a nucleus at the centre and electrons orbiting around it. This picture is simplified, not quite accurate in terms of quantum mechanics, but it captures something essential about the scale of emptiness within atoms. If an atom were enlarged to the size of a cathedral, the nucleus would be about the size of a housefly hovering in the centre, and the electrons would be like specks of dust orbiting in the vast empty space of that huge building. All the rest would be void, emptiness, nothing we can detect or measure except for the fields that fill it. Let's put this in perspective with actual numbers. The nucleus of a hydrogen atom, a single proton, has a radius of about 0.88 femtometers, where a femtometer is 10 to 15 meters, a millionth of a billionth of a meter. The electron in a hydrogen atom orbits at an average distance of about 53,000 femtometers from the nucleus. That means the atom is about 60,000 times larger than its nucleus. If the nucleus were the size of a marble, the electron would be orbiting about half a mile away, and everything in between would be empty space. But even this vastly understates the emptiness, because the electron isn't really a tiny ball orbiting at that distance. In quantum mechanics, the electron is described by a wave function, a probability cloud that tells us where we might find it if we look. Most of this probability cloud is empty space where the electron definitely isn't at any given moment. The electron occupies an incomprehensibly tiny fraction of the space we call its orbital. It is not even accurate to say it orbits. It exists in a quantum state, appearing and disappearing, being everywhere and nowhere until observed. And what about the nucleus itself, that tiny speck at the atom's heart that contains nearly all its mass? Surely that must be solid. But no, even the nucleus is mostly empty. Protons and neutrons, the particles that make up the nucleus, are themselves made of quarks, and quarks are point particles as far as we can tell, having no size at all in the classical sense. The proton is not a solid ball, but a cloud of virtual particles, a seething quantum storm of quarks and gluons appearing and disappearing, with the three real quarks that define the proton being just persistent patterns in this storm. Recent experiments have probed the structure of protons with unprecedented precision, and what they've found is remarkable. The three quarks that make up a proton account for only about 1% of its mass. The rest comes from the energy of the gluon field that binds the quarks together, from the virtual quarks and antiquarks constantly appearing and disappearing, from the sheer intensity of quantum activity in what we might think of as the empty space inside the proton. The proton is not a thing but a process, not a solid but a standing wave in quantum fields, a stable pattern in the seething vacuum. So your hand, which seems so solid, is made of atoms that are 99.9999999% empty space, and even the tiny part that isn't empty space in the conventional sense is itself mostly energy fields and virtual particles rather than anything we could call solid in the everyday sense. If you could somehow remove all the empty space from all the atoms in your body, compress all the actual stuff together, you would be smaller than a grain of sand. All of humanity, all 7 billion of us, compressed to actual solid matter without empty space, would fit into the volume of a sugar cube. But wait, you might say, if atoms are mostly empty space, why can't I put my hand through the table? Why does matter seem solid at all? The answer involves the quantum mechanical nature of electrons and something called the Pauli exclusion principle. Electrons are fermions, particles that obey a rule saying no, two electrons can occupy the same quantum state. When atoms get close together, their electron clouds overlap, and the electrons must rearrange themselves to avoid violating this principle. This rearrangement requires energy, creating a repulsive force that we experience as solidity. Think about what this means. The solidity you feel is not stuff pushing against stuff, but a quantum mechanical rule about how electron probability clouds can overlap. It's not matter resisting matter, but patterns in quantum fields maintaining their distinctness. When you touch the table, the electrons in your hand and the electrons in the table never actually touch in any classical sense. They come close enough that their wave functions overlap, and quantum mechanics says no closer, creating the sensation of contact without any actual solid things touching. This becomes even stranger when we consider chemical bonds, the forces that hold atoms together in molecules. A chemical bond is not a physical connection like a rope or a rod. It's a sharing or exchange of electrons, an overlap of probability clouds, a quantum entanglement between atoms. The molecules that make up your body are not solid structures, but dynamic patterns of probability, constantly shifting and adjusting, held together not by solid connections but by the mathematics of quantum mechanics. Water, that most familiar of substances, provides a perfect example. A water molecule is two hydrogen atoms bonded to one oxygen atom, H2O. But what does this really mean? The oxygen nucleus and two hydrogen nuclei are tiny points separated by vast empty spaces. The electrons form probability clouds around and between these nuclei, creating regions of negative charge that hold the positive nuclei in place. But it's all empty space and probability. The water molecule is not a thing but a pattern, a stable arrangement of quantum fields in mostly empty space. And yet water feels wet. It has surface tension. It can be solid ice or flowing liquid or invisible vapor. How can patterns of emptiness create such tangible properties? The answer lies in how these patterns interact. Water molecules are polar, with a slightly positive side and a slightly negative side, and these electrical differences cause molecules to attract each other, forming hydrogen bonds. These bonds are even less substantial than the chemical bonds within molecules, just weak electrical attractions between patterns of probability, yet they give water all its familiar properties. Consider ice, which seems absolutely solid, crystalline, hard enough to skate on. But ice is just water molecules arranged in a regular pattern, and water molecules are just atoms arranged in patterns, and atoms are mostly empty space. The hardness of ice is not due to solid matter, but to the rigid organization of mostly empty patterns. It's like a formation of dancers maintaining precise positions. The formation can be rigid and resist deformation even though it's mostly empty space between dancers. The rigidity comes from the pattern, not from solidity. The same principle applies to all solid matter. Diamond, the hardest natural substance, is just carbon atoms arranged in a particular pattern. but carbon atoms are mostly empty space, and the bonds between them are probability clouds of electrons. The incredible hardness of diamond comes not from solid matter, but from the strength and geometry of the pattern, the way the electron clouds overlap and resist reorganization. You could say diamond is mostly empty space arranged in an exceptionally stable pattern. Metals provide another fascinating example. In a metal like gold or silver, some electrons are not bound to specific atoms, but form a sea of electrons that can move freely through the material. This electron sea is what makes metals conduct electricity and heat, what gives them their characteristic luster. But again, it's all patterns in mostly empty space. The gold in a wedding ring is not solid matter, but a stable arrangement of atomic nuclei in a sea of electrons, all of it mostly void with patterns of probability creating the illusion of solidity and the reality of function. Let's go deeper into the quantum nature of matter. According to quantum field theory, particles are not tiny solid balls, but excitations in quantum fields. An electron is a wave in the electron field. A proton is a pattern in quark and gluon fields. These fields fill all of space, and what we call particles are just places where the fields are excited, where waves have enough energy and stability to persist. Matter is not stuff in empty space, but patterns of excitation in the fullness of quantum fields. This view completely inverts our usual understanding. Instead of solid particles moving through empty space, we have patterns of excitation in full fields. The electron in a hydrogen atom is not a thing orbiting another thing, but a standing wave in the electron field, shaped and sustained by the electromagnetic field of the proton. The proton itself is not a solid ball, but a complex stable pattern in quark and gluon fields. The atom as a whole is not a thing, but a self-sustaining pattern of excitations in multiple interpenetrating quantum fields. From this perspective, your entire body is not made of solid matter, but of patterns in quantum fields. These patterns are incredibly complex, incredibly stable, incredibly organized, but they're still just patterns, not things. You're not solid matter temporally organized into life, but a temporary organization of patterns in the fullness of quantum fields. The distinction between you and the space around you is not the distinction between something and nothing, but between different patterns in the same underlying fields. Consider what happens when you eat and breathe. Atoms from food and air become part of your body, while atoms that were part of your body are exhaled or excreted. In the conventional view, you're exchanging solid matter, taking in particles and releasing others, but in the quantum field view, you're reorganizing patterns. The patterns that were food become patterns that are you. The patterns that were you become patterns that are waste or breath. You're not a collection of particles, but a persistent pattern that maintains its form while constantly exchanging its substance. Scientists estimate that about 98% of the atoms in your body are replaced every year. In a very real sense, you're not made of the same matter you were made of a year ago. What persists is not the matter, but the pattern, not the particles, but their organization. You're like a wave that maintains its shape while moving through water, or a flame that keeps its form while constantly consuming new fuel and releasing exhaust. The matter flows through you, but the pattern persists, and the pattern is what you are. This pattern view of matter helps explain many mysteries. Why do all electrons have exactly the same mass and charge? Because they're all excitations of the same electron field, like waves in the same ocean naturally having the same properties. Why can particles be created and destroyed in particle accelerators? Because they're not permanent things, but temporary patterns that can form and dissolve. Why does quantum mechanics describe particles as waves? Because they are waves in quantum fields, and particle-like behavior emerges only in certain circumstances. The view of matter as patterns in mostly empty space also aligns with what we know about energy and mass. Einstein's famous equation, E mc2, tells us that mass and energy are interchangeable, that matter can be converted to energy and vice versa. This makes perfect sense if matter is patterns of energy in quantum fields rather than solid stuff. The mass of a particle is just the energy required to create that particular pattern of excitation in the field. When matter is converted to energy in nuclear reactions, patterns are dissolving back into the underlying fields. When energy creates matter in particle accelerators, the fields are being excited into new patterns. Even the stability of matter becomes less mysterious from this perspective. Why don't atoms spontaneously collapse or fly apart? because they represent stable patterns in quantum fields, like standing waves that maintain their form. These patterns are stable not because they're made of solid permanent stuff, but because they represent energy minima, configurations that require energy to change. It's like a valley between hills. A ball will naturally roll to the valley and stay there, not because the valley is made of different stuff, but because it's the lowest energy configuration in that landscape. The illusion of solidity, then, comes from the stability and interaction of these patterns. When patterns in quantum fields interact in ways that preserve their organization, we experience solidity. When they interact in ways that allow reorganization, we experience fluidity or gas. When patterns dissolve entirely, we experience dissolution or evaporation. But it's all patterns in fields, all arrangements of mostly empty space, all dances of probability in the quantum vacuum. As we contemplate this view of matter as islands of pattern in an ocean of space, we might wonder what defines the patterns. What makes one arrangement of quantum field excitations an electron and another a quark? What maintains the stability of these patterns over time? The answer seems to be the laws of physics themselves, the rules that govern how quantum fields can vibrate, how they interact, how energy flows between them. These laws are like the grammar of reality, determining what patterns are possible, which are stable, how they can transform into each other. But where do these laws come from? Why these particular laws and not others? Here we approach the deepest mysteries, questions that science has not yet answered and perhaps cannot answer. Some physicists suggest that the laws of physics are themselves properties of space, that what we call empty space comes with built-in rules about how patterns can form within it. If this is true, then space is not just a passive container, but an active participant in physics, not just the stage but also the director, guiding how the cosmic drama unfolds. This brings us full circle to our central question. If matter is mostly empty space organized into patterns, and if these patterns are governed by properties of space itself, then perhaps space is the fundamental reality and matter is derivative. Perhaps what we call solid matter is just a special organization of the deeper solidity of space. Perhaps the distinction between matter and space, between something and nothing, is not fundamental but depends on perspective, on scale, on how we choose to describe the seamless unity of quantum fields that fill all of existence. Your body, this seemingly solid collection of matter, is revealed as a vast emptiness organized into meaningful patterns. But this emptiness is not void. It's filled with quantum fields, virtual particles, zero-point energy, all the texture of nothing we explored earlier. And the patterns are not arbitrary but follow the deep laws encoded in space itself. You're not a solid thing in empty space, but a beautiful, complex, self-sustaining pattern in the fullness of quantum fields, a dance of probability in the solid substrate of space itself. As you lie there, feeling the seeming solidity of your body, remember that this feeling is itself part of the illusion, or rather, part of the limited perspective from which we normally experience reality. At the scale of atoms, you are mostly empty space. At the scale of quantum fields, you are patterns in fullness. At the scale of space-time, you might be ripples in a deeper solidity we're only beginning to understand. Each perspective is true, but none is complete. The full truth encompasses all scales, all perspectives, revealing matter and space not as opposites, but as complementary aspects of a single, unified reality. The islands of matter floating in the sea of space are not really islands at all, but waves, temporary rises in the level of the sea, patterns that emerge from and return to the ocean of quantum fields. And perhaps that ocean, what we call empty space, is the true solid, the fundamental substrate, the ground of being from which all patterns arise. Matter would then be not the opposite of empty space, but a special configuration of it, a way that space organizes itself into the beautiful complexity we see around us and within us. Now we venture into one of the most profound reconceptions of reality that human thought has achieved. The understanding that space and time are not separate entities, but woven together into a single fabric called space-time, and that this fabric is not passive and featureless, but dynamic and structural, capable of bending, stretching, rippling like the surface of a cosmic ocean. What if this space-time, this union of space and time that Einstein revealed to us, is not the empty stage on which cosmic events unfold, but the solid foundation that supports and shapes everything we know? What if we are not moving through empty space but walking on, swimming through, existing within a kind of solid sky that we cannot see but that touches and defines us at every moment? Let's begin with the familiar experience of gravity, that force that keeps your body pressed against your bed, that defines up and down, that orchestrates the dance of planets around stars and stars around galactic centers. For most of human history, gravity was understood as a force, a mysterious attraction between objects with mass, reaching across empty space to pull things together. Newton described it mathematically, but admitted he had no idea how it actually worked, how objects could influence each other across the void with no visible connection between them. Einstein changed everything with a simple but radical idea. What if gravity is not a force at all, but a consequence of the shape of space-time? What if massive objects don't pull on each other through empty space, but instead bend the space-time around them, and objects moving through this bent space-time naturally follow curved paths that we interpret as gravitational attraction? It's like placing a bowling ball on a stretched rubber sheet. The ball creates a depression, and marbles rolled nearby will curve toward the ball not because the ball is pulling them, but because they're following the curvature of the sheet. But this analogy, helpful as it is, doesn't capture the full strangeness of what Einstein discovered. The rubber sheet is a two-dimensional surface curved in three-dimensional space, but space-time is four-dimensional, 3 of space and 1 of time, and its curvature doesn't happen in some higher dimensional space but is intrinsic to space-time itself. The curvature is not something that happens to space-time, but something that space-time does, a property it can have, a way it can be. Think about what this means for the space around you right now. You're sitting or lying in Earth's gravitational field, which means you're in a region of curved space-time. The space near Earth is not the same as the space far from Earth. It's bent, warped, given a geometry that guides the motion of everything within it. The floor beneath you is accelerating upward through curved space-time, and when it meets your body, which would naturally follow a curved path through that space-time, you experience the contact as weight, as the feeling of gravity. This is why Einstein realized that someone falling freely feels no weight. When you jump during those brief moments in the air, you're following the natural path through curved space-time, and gravity seems to disappear. It's not that gravity stops working, but that gravity is the curvature, and when you move along with the curvature, you don't feel it. Only when something like the floor prevents you from following the curved path do you feel weight, feel the presence of gravity. But if space-time can be curved, if it has geometry that can change, doesn't this suggest that it's something rather than nothing? Empty nothingness can't have shape. Void can't have geometry. Only something with substance, with properties, with a kind of existence can be curved or straight, stretched or compressed. The very fact that space-time can be warped by mass and energy suggests that it's not empty but full, not absent but present, not nothing but very much something. General relativity, Einstein's theory of gravity, describes space-time using mathematical objects called tensors that specify the curvature at every point. These equations, the Einstein field equations, relate the curvature of space-time to the energy and matter within it. But the equations work both ways. Not only does matter curve space-time, but the curvature of space-time tells matter how to move. As physicist John Wheeler famously put it, matter tells space-time how to curve, and space-time tells matter how to move. This two-way relationship suggests that space-time is not just a passive backdrop, but an active participant in physics. It's not just curved by matter, but responds to matter, pushes back, guides and constrains how matter can move and exist. When you walk across a room, you're not moving through empty space, but through curved space-time, and that curvature is guiding your motion just as surely as the floor is supporting your feet. Consider the Global Positioning System, GPS, that many of us use daily. GPS satellites orbit Earth at high altitude, where space-time is less curved than at Earth's surface because they're farther from Earth's mass. This means time runs faster on the satellites than on the ground, a difference of about 38 microseconds per day. If this relativistic effect weren't corrected for, GPS would accumulate errors of about 10 kilometers per day. The fact that your phone can tell you where you are within meters is proof that space-time is real, that its curvature affects the flow of time, that we live within a structured, responsive medium, not an empty void. But space-time doesn't just curve gradually around massive objects, it can also ripple, carrying waves that Einstein predicted and that were finally detected a century later. Gravitational waves are ripples in space-time itself, caused by accelerating masses, especially dramatic events like colliding black holes or neutron stars. These waves stretch and compress space-time as they pass, actually changing the distance between objects, though by incredibly tiny amounts. The LIGO and Virgo detectors have now detected dozens of gravitational wave events, ripples in space-time from collisions that happened billions of years ago and billions of light-years away. Think about what this means. Space itself can carry waves. It can vibrate, oscillate, transmit information and energy. Empty nothingness can't do this. Only something with substance, with properties analogous to elasticity and inertia, can support waves. The detection of gravitational waves is direct evidence that space-time is not nothing but something, not empty but substantial. These gravitational waves travel at the speed of light, suggesting a deep connection between the structure of space-time and the fundamental speed limit of the universe. Nothing can travel faster than light, not because of some arbitrary rule, but because that's the speed at which space-time itself can transmit information, the speed at which cause and effect can propagate through the fabric of reality. It's as if space-time has a kind of rigidity, a maximum rate at which disturbances can spread through it, just as sound waves in air or water have maximum speeds determined by the properties of those media. The speed of light, then, might be telling us something about the nature of space-time itself. It might be like the speed of sound in a material, revealing the relationship between the medium's elasticity and density. If space-time is a kind of solid, a substrate with physical properties, then the speed of light might be determined by these properties, by how stiff or flexible space-time is, by how quickly it can respond to changes. Black holes provide perhaps the most dramatic evidence for the substantial nature of space-time. A black hole is not a hole in space, but a region where space-time is curved so extremely that it folds in on itself, creating a region from which nothing can escape. The event horizon, the boundary of a black hole, is not a physical surface, but a geometric property of space-time, the point beyond which all paths through space-time lead inward. If space-time were nothing, how could it be curved so extremely? How could emptiness fold in on itself? The existence of black holes makes sense only if space-time is something that can be deformed, stretched to breaking point, twisted into configurations so extreme that they trap even light. The black hole is not an object in space, but a feature of space-time itself, like a whirlpool is not a thing in water but a configuration of water. Even more remarkably, black holes have thermodynamic properties. They have temperature, proportional to their surface gravity. They have entropy, proportional to their surface area. They emit Hawking radiation, a quantum effect where virtual particles near the event horizon can become real, with one falling into the black hole and the other escaping. These properties make sense only if space-time is not empty but full of quantum fields, virtual particles, zero-point energy, all the texture of nothing we explored earlier. The holographic principle, one of the most mind-bending ideas in modern physics, suggests that all the information in a volume of space-time can be encoded on its boundary, like a hologram that stores three-dimensional information on a two-dimensional surface. This principle, which seems to be true for black holes and might be true for space-time in general, implies that space-time has information content, that it can store and process information. Empty nothing can't store information. Only something with structure, with degrees of freedom, with the ability to be in different states can carry information. Let's consider what it might mean to walk on this solid sky, to move through space-time as if it were a substantial medium rather than empty void. Every step you take displaces space-time, creates tiny ripples in its fabric, though far too small to detect with current technology. Your mass curves the space-time around you slightly, creating a tiny gravitational field that extends throughout the universe, weakening with distance but never quite reaching zero. When you move, you're not just changing your position in space, but tracing a path through space-time, what physicists call a world line. This world line is not just a trajectory, but a kind of groove in space-time, a record of your existence written in the fabric of reality itself. The faster you move through space, the slower you move through time, as if you're always moving at the speed of light through space-time but can trade motion through space for motion through time. This trade-off, this connection between space and time, suggests they're not separate dimensions but aspects of a single entity. You can't have space without time, or time without space. They're woven together inextricably like the warp and weft of a fabric. And this fabric, this space-time, is not static but dynamic, not fixed but flexible, capable of being stretched by the expansion of the universe, compressed by the presence of mass, rippled by accelerating objects. The expansion of the universe provides another window into the nature of space-time. Distant galaxies are moving away from us, and the farther away they are, the faster they're receding. But they're not moving through space in the conventional sense. Instead, space itself is expanding, carrying galaxies along like raisins in rising bread dough. New space is being created between galaxies, stretching the wavelength of light as it travels, causing the cosmic redshift we observe. But how can space be created? How can nothing come from nothing? This makes sense only if space is not nothing but something, a substance that can be produced, a medium that can grow. The expansion of the universe is not stuff moving apart through emptiness, but emptiness itself growing. Except it's not really emptiness, but the substantial fabric of space-time increasing, stretching, creating more of itself. Dark energy, that mysterious force causing the expansion to accelerate, appears to be a property of space-time itself. Every cubic meter of space contains a tiny amount of dark energy, a kind of negative pressure that pushes space to expand. As space expands and creates more space, it creates more dark energy, leading to ever faster expansion. This suggests that space-time is not inert but active, not neutral but biased toward expansion, as if it wants to grow, wants to create more of itself. Some theories suggest that space-time might be emergent, not fundamental but arising from something deeper. Just as temperature emerges from the motion of atoms, space-time might emerge from more fundamental entities, perhaps quantum bits of information, perhaps vibrating strings in higher dimensions, perhaps networks of quantum entanglement. If this is true, then the solid sky we walk on might itself be a kind of illusion, or rather a higher-level description of something even more fundamental. But emergent or fundamental, space-time behaves as if it's substantial. It can be curved by mass, rippled by acceleration, stretched by expansion. It has properties: a speed limit for information transmission, a quantum structure at the smallest scales, thermodynamic properties near black holes. It can store information, guide the motion of matter, determine the flow of time. These are not properties of nothing but of something, not characteristics of absence but of presence. The quantum nature of space-time, though not yet fully understood, hints at even deeper substance. At the Planck scale, about 10⁻35 meters, space-time might not be smooth but foamy, constantly fluctuating, with virtual black holes appearing and disappearing, with the geometry itself uncertain and probabilistic. This quantum foam would give space-time a texture at the smallest scales, a granularity that might be the fundamental pixels of reality. If space-time is quantized, made of discrete units rather than continuous, then it's even more obviously something rather than nothing. It would be like discovering that what looks like smooth water is actually made of molecules, that what seems like continuous space is actually a network or lattice at the smallest scale. The solid sky would be revealed as having structure all the way down, organization at every level, substance at every scale. Consider the implications for your daily experience. When you walk across a room, you're not moving through emptiness, but through a structured medium that guides your motion. When you feel the weight of your body, you're feeling the curvature of space-time, the way Earth's mass has shaped the invisible ocean in which you're immersed. When you see the stars, you're receiving light that has traveled through this ocean, following the curves and ripples of space-time, carrying information about distant events across the solid sky. Even your thoughts, the electrical and chemical signals in your brain propagate through space-time, are shaped by its structure, limited by its speed of information transmission. Your consciousness exists within and depends upon the fabric of space-time. You're not separate from it, but part of it, a pattern within it, a local organization of the fields and particles that exist within its framework. The solid sky is not just beneath your feet, but within you, around you, constituting the very possibility of your existence. As we contemplate space-time as a hidden ocean, a solid sky that we walk upon without seeing, we begin to understand why the universe behaves as it does. Gravity is not a mysterious force acting at a distance, but the curvature of this ocean. Light's finite speed is not an arbitrary limit, but the rate at which waves can propagate through this medium. The expansion of the universe is not motion through nothing but the growth of the medium itself. And perhaps most profoundly, the fact that space-time can be curved, can carry waves, can expand and contract, suggests that what we call empty space is the opposite of empty. It's full of potential, rich with structure, pregnant with possibilities. It's not the absence between things, but the presence that allows things to be. Not the void that separates, but the ocean that connects. Not emptiness, but perhaps the most solid, substantial, fundamental thing there is. Walking on this solid sky, swimming through this hidden ocean, we are not isolated objects in a void, but patterns in a plenum, waves in a medium, temporary organizations of something far deeper and more permanent than ourselves. The space-time that seems like nothing is revealed as everything, the invisible foundation that supports all visibility, the intangible substance that makes all tangibility possible. As you lie there, feeling the gentle pressure of gravity, remember that this is the solid sky pressing against you, the curved ocean of space-time guiding your body toward Earth's center. The space around you is not empty, but full of this invisible presence, this substantial absence, this something that masquerades as nothing. You're not in space-time but of it, not separate from it, but a manifestation of its ability to curve and twist and organize itself into the beautiful complexity of existence. Throughout human history, we have sent our mechanical ambassadors into what we call the void, those brave spacecraft that venture beyond Earth's protective embrace into the supposed emptiness between worlds. Each mission has been a journey into what we expected to be nothing, and each has discovered that nothing is far more complex, structured, and substantial than we ever imagined. These robotic explorers have become our extended senses, touching the untouchable, measuring the immeasurable, sending back whispers from the cosmic silence that tell us the void is anything but empty. Let's begin with the Voyager spacecraft, perhaps humanity's most famous messengers to the darkness. Launched in 1977, Voyager 1 and Voyager 2 have now travelled farther from Earth than any human-made objects, crossing the boundary of our solar system and entering what we call interstellar space. For over 4 decades, they have been measuring what lies in the spaces between planets, between solar systems, in the vast reaches we once thought were perfect vacuum. What Voyager found as it approached the edge of our solar system was not a gradual fade into emptiness, but a complex boundary region called the heliopause, where the solar wind from our Sun meets the interstellar medium. This boundary, over 11 billion miles from the Sun, is not empty but filled with turbulent magnetic fields, cosmic rays, and interstellar particles. It's like the place where a river meets the ocean, a zone of mixing and interaction, proving that even the boundary between our solar system and interstellar space is not a transition from something to nothing, but from one kind of something to another kind of something. Scientists have observed through Voyager's instruments that interstellar space has a different density of particles than the space within our solar system. There are about 0.1 particles per cubic centimetre in interstellar space near our solar system, compared to about 5 particles per cubic centimetre in the solar wind. These numbers might seem tiny, almost nothing, but when you multiply them by the vast volumes of space, they represent enormous amounts of matter, all drifting through what we call the void. Voyager has shown us that the emptiness between stars is actually a thin sea, a medium with measurable properties, temperature, density, composition. The spacecraft's magnetometer has revealed that interstellar space is threaded with magnetic fields, about 5 to 10 microgauss in strength. These fields are not emanating from any nearby star, but are part of the galactic magnetic field, the vast magnetic structure that permeates our entire galaxy. The void is magnetized, organized, given direction and structure by these invisible fields. It's as if space itself has a grain, a preferred orientation, channels along which charged particles flow and around which matter organizes itself. Voyager's cosmic ray subsystem has detected a dramatic increase in galactic cosmic rays as it left the solar system's protective magnetic bubble. These high-energy particles, accelerated by supernovas and other violent cosmic events, fill interstellar space, constantly crossing the void at nearly the speed of light. The emptiness is actually buzzing with these particles, a constant rain of high-energy radiation that would be lethal to unprotected life, but that reveals the void as an active, energetic medium rather than passive emptiness. Perhaps most remarkably, Voyager 1's plasma wave instrument has detected vibrations in the interstellar medium, actual sounds in the void, though at frequencies far below what human ears can hear. These plasma waves are caused by oscillations in the ionized gas of interstellar space, creating a kind of cosmic hum that Voyager has recorded and sent back to Earth. Scientists have sped up these recordings to make them audible, and what we hear is haunting. The void is singing, a deep ethereal drone that speaks of the hidden substance of space itself. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, provided different insights into the nature of the void. As it travelled between Saturn's rings, through gaps that appeared empty, it found nothing but a complex environment of tiny particles, electromagnetic phenomena, and gravitational influences. The seemingly empty space between ring particles was filled with plasma, charged particles trapped in Saturn's magnetic field, creating invisible structures as complex as the visible rings themselves. Cassini's dive between Saturn and its rings in the spacecraft's final orbits before its planned destruction was expected to encounter empty space. Instead, it found a surprising amount of material, tiny dust particles that created an unexpected ring rain falling from the rings onto Saturn. The void between planet and rings was not void at all, but filled with a constant flow of material, a waterfall of particles invisible to our eyes, but clearly detected by Cassini's instruments. The spacecraft also measured Saturn's magnetic field with unprecedented precision, discovering that it's almost perfectly aligned with the planet's rotation axis, a mystery that scientists are still trying to understand. This magnetic field extends far beyond Saturn, creating a vast magnetosphere that shapes the space around it, organizing charged particles into radiation belts, auroras, and complex plasma structures. The emptiness around Saturn is actually full of these invisible structures, shaped and maintained by the planet's magnetic influence. Moving closer to home, the Parker Solar Probe, launched in 2018, is humanity's first mission to touch the Sun, flying through the solar corona where temperatures exceed 1,000,000 degrees. But what is the corona? It's the Sun's outer atmosphere, a region that looks empty compared to the dense solar surface, but is actually filled with superheated plasma, magnetic fields, and the nascent solar wind. Parker has shown us that this apparent void is one of the most dynamic, energetic environments in our solar system. The probe has discovered magnetic switchbacks in the solar wind, sudden reversals in the magnetic field that whip back and forth like a cracking whip. These structures were completely unexpected, revealing that the void near the Sun is not a smooth outflow of particles, but a turbulent, complex medium with structure at all scales. The empty space through which Earth orbits is actually filled with these magnetic waves and reversals, constantly washing over our planet, though our magnetic field protects us from most of their effects. Parker has also measured the dust-free zone around the Sun, a region where the intense heat and radiation have vaporized all dust particles. This zone was theorized but never observed until Parker flew through it. The boundary of this zone is not a wall, but a gradual transition where the void goes from dusty to clean, showing that even emptiness has varieties, gradations, different flavors of nothing that are actually different kinds of something. The New Horizons mission to Pluto and beyond has given us insights into the Kuiper Belt, that vast region of icy bodies beyond Neptune. As New Horizons travelled through this region, its instruments measured the interplanetary medium, finding that even billions of miles from the Sun, space is not empty, but filled with solar wind, albeit much more tenuous than near Earth. The spacecraft detected unexpected levels of dust, suggesting that the outer solar system's void is hazier than we thought, filled with tiny particles ground off Kuiper Belt objects by cosmic rays and micrometeorite impacts. New Horizons' measurements of the cosmic optical background, the total amount of light from all sources in the universe, found it to be twice as bright as expected from known galaxies alone. This suggests that the void is filled with light from sources we haven't yet identified, perhaps from galaxies too faint to see, perhaps from some unknown phenomenon. The darkness of space is not truly dark, but filled with a faint glow, a cosmic background illumination that permeates even the emptiest regions. The spacecraft has also been measuring the heliopause from the inside as it approaches this boundary, complementing Voyager's measurements from the outside. Together, these missions are mapping the shape and structure of the bubble our Sun creates in the interstellar medium, showing that the boundary between solar and interstellar space is not a simple sphere, but a complex, possibly comet-shaped structure influenced by the Sun's motion through the galaxy and the pressure of the interstellar medium. IBEX, the Interstellar Boundary Explorer, though it orbits Earth, studies the distant boundary of our solar system by detecting energetic neutral atoms that are created when the solar wind meets the interstellar medium. These atoms travel across the solar system, taking years to reach Earth, carrying information about conditions at the heliopause. IBEX has discovered a ribbon of enhanced emissions that wasn't predicted by any model, suggesting that the boundary region has structure and complexity we're only beginning to understand. This ribbon might be caused by the galactic magnetic field organizing particles at the boundary, creating a kind of cosmic magnetic mirror that reflects particles back toward us. If this is correct, it means the void of interstellar space is not just passively receiving our solar wind, but actively shaping it, organizing it, sending signals back to us about its own structure and properties. The emptiness is responsive, interactive, engaged in a dialogue with the matter passing through it. The Hubble Space Telescope, orbiting above Earth's atmosphere, has peered deeper into the cosmic void than any previous instrument, and everywhere it looks, it finds not emptiness but structure. The famous Hubble Deep Field images, created by pointing the telescope at apparently empty patches of sky for days at a time, revealed thousands of galaxies in regions that looked completely dark to other telescopes. The void between galaxies is filled with light, just too faint for our eyes or ground-based telescopes to see. Hubble has also detected the cosmic web directly, observing the faint filaments of gas that connect galaxies across millions of light-years of apparent emptiness. These filaments, made mostly of hydrogen, are incredibly tenuous, with densities of just a few particles per cubic meter, but they contain more matter than all the galaxies combined. The void is not empty but structured, organized into a vast network that guides the formation and evolution of galaxies. The James Webb Space Telescope, launched in 2021, is now extending our vision even further, detecting light from the universe's first galaxies, traveling through billions of light-years of supposed void to reach us. But this light doesn't travel unchanged. It's redshifted by the expansion of space, absorbed, and re-emitted by intervening gas gravitationally lensed by dark matter. The void between us and these distant galaxies is not passive but active, processing the light, encoding information about everything it passes through. Webb has detected molecules in the atmospheres of distant exoplanets by measuring how starlight changes as it passes through these atmospheres. This technique works only because space is transparent to certain wavelengths of light, yet this transparency is not the transparency of nothingness, but the selective transparency of a medium with specific properties. Different wavelengths interact differently with the quantum fields that fill space, with the virtual particles that pop in and out of existence, with the cosmic dust and gas that drift through the void. Radio telescopes have revealed yet another aspect of the void's hidden substance. They detect radio waves from distant pulsars, neutron stars that spin rapidly, sending out beams of radiation like cosmic lighthouses. As these radio waves travel through space, they're delayed by interactions with free electrons in the interstellar medium. This delay, called dispersion, depends on the frequency of the radio waves and the density of electrons along the path. By measuring this dispersion, astronomers can map the electron density of the void, revealing that space is not empty, but filled with a thin plasma that varies in density and temperature. The LIGO and Virgo gravitational wave detectors have shown us that the void can carry ripples in spacetime itself. When black holes collide billions of light-years away, they send out gravitational waves that travel through the cosmic void, stretching and squeezing space as they pass. These waves travel at the speed of light, unimpeded by intervening matter, because they're not traveling through space but are waves of space itself. The void is not just a passive container but an elastic medium that can vibrate, carrying information about cosmic catastrophes across the universe. The IceCube Neutrino Observatory in Antarctica detects neutrinos, ghostly particles that barely interact with matter, that have travelled through the cosmic void from distant sources. These neutrinos pass through planets, stars, and vast reaches of space almost as if nothing were there. Yet occasionally one interacts with the ice in Antarctica, creating a flash of light that Ice Cube detects. The fact that neutrinos can travel such vast distances tells us something about the void. It's transparent to neutrinos not because it's empty, but because neutrinos interact only through the weak nuclear force, revealing another layer of the void's complex structure. Each space mission, each telescope, each detector adds another piece to our understanding of the void. They all tell the same story. What we call empty space is not empty but full of fields, particles, waves, structures. The void has temperature, density, composition, magnetic fields, electric currents. It can be compressed by gravity, stretched by expansion, rippled by gravitational waves. It carries light, cosmic rays, neutrinos, gravitational waves, magnetic fields. It's not nothing but something, not absence but presence, not empty but full of a subtle, complex, dynamic substance we're only beginning to understand. As our spacecraft venture farther into what we call the void, they're not entering emptiness but exploring new regions of the cosmic ocean. Each measurement they make, each signal they send back, tells us more about the nature of this ocean. The solar wind shows us how stars fill the void with particles and magnetic fields. The cosmic rays show us how supernovas energize the void across vast distances. The gravitational waves show us how the void itself can vibrate and carry information. Perhaps most remarkably, these missions have shown us that the void is not uniform but varied, structured, organized. There are regions of different density, temperature, magnetic field strength. There are boundaries and transitions, currents and turbulence. The void near stars is different from the void between stars, which is different from the void between galaxies. Each region has its own characteristics, its own properties, its own way of being not empty. The Breakthrough Starshot initiative proposes sending tiny spacecraft to nearby stars, using powerful lasers to accelerate them to a significant fraction of the speed of light. These craft would need to survive the journey through interstellar space, through the void between stars. The engineering challenges reveal more about the nature of the void. It's not empty but filled with dust that could destroy a fast-moving spacecraft, cosmic rays that could fry its electronics, magnetic fields that could deflect its course. The void is not passive but hostile to fast travel, not because it's empty but because it's full of hazards we're only beginning to catalogue. Future missions will probe even deeper into the nature of the void. The proposed interstellar probe would travel farther and faster than Voyager, reaching hundreds of astronomical units from the Sun to study the heliopause, an interstellar medium in detail. The Laser Interferometer Space Antenna, LISA, will detect gravitational waves from space, free from the seismic noise that limits ground-based detectors, revealing how the void vibrates at frequencies we've never observed. The Roman Space Telescope will map dark matter and dark energy, the invisible components that make up most of the universe's content. Each of these missions will add to our understanding that the void is not void, that emptiness is not empty, that space is not nothing but something. They're not exploring absence but presence, not measuring nothing but cataloguing the properties of a subtle, pervasive, essential something that fills all of space. The void speaks to those who know how to listen, and our spacecraft are teaching us its language. As you lie there in the darkness, perhaps you can imagine these distant spacecraft, our mechanical scouts in the cosmic ocean. Voyager, still transmitting after all these years, its signal taking over 21 hours to reach Earth from its position in interstellar space. Parker, diving through the Sun's corona, touching our star. New Horizons heading into the Kuiper Belt's darkness, each one alone in what seems like emptiness, but is actually full of phenomena to measure, structures to map, mysteries to uncover. These missions have transformed our understanding of space from a void to be crossed to an ocean to be explored. They've shown us that travelling through space is not moving through nothing, but navigating a complex medium with currents and weather, structure and substance. The void has gone from being the absence between things to being the thing itself, the medium in which all else exists, the substantial foundation that we once mistook for emptiness. And perhaps this is the greatest discovery of our space missions, not any particular measurement or observation, but the cumulative realization that we've been wrong about the void all along. It's not empty, but full. Not nothing but something, not void but plenum. Our spacecraft haven't ventured into nothingness, but into a subtle, complex, structured medium that we're only beginning to understand. They've touched the nothing and found it to be something, listened to the silence and heard it singing, measured the vacuum and found it full of energy and information. The void between stars is not a barrier but a bridge, not emptiness but the medium through which stars communicate via light and gravity. The void between galaxies is not absence, but the scaffolding on which galaxies hang, the cosmic web that guides their formation and evolution. The void within atoms is not nothingness, but the quantum fields that give particles their properties. At every scale, what seems empty is revealed to be full. What appears to be nothing turns out to be the most fundamental something of all. As our journey through the night continues, and we prepare to imagine what it would mean if this understanding were taken to its logical conclusion, if space really is solid and matter really is empty, remember these mechanical pioneers that have ventured into the darkness on our behalf. They've shown us that the darkness is not dark, the silence is not silent, the void is not void. They've been our hands reaching into the cosmic ocean, our ears listening to its whispers, our eyes seeing its invisible structures. And what they've found changes everything about how we understand our place in the universe. Let us now journey into the realm of imagination, where we take everything we've discovered about the nature of space and matter and ask, what would it truly mean to live in a universe where space is solid and matter is empty? Not as metaphor or philosophy, but as lived experience, as the fundamental reality underlying everything we see and feel and know. Close your eyes for a moment and let your mind drift into this inverted cosmos, where everything you've taken for granted is gently, peacefully turned inside out, revealing a universe more beautiful and connected than we ever imagined. Imagine waking up tomorrow with the sudden ability to perceive reality as it truly is, to see past the illusion of solid matter and empty space to the deeper truth beneath. As you open your eyes, the room around you would look different, though not in any alarming way. The walls, the furniture, your own body would shimmer slightly like mirages, because you'd be seeing them for what they really are: intricate patterns in the solid substrate of space, temporary arrangements of hollowness in an otherwise continuous medium. Your hand, as you raise it before your eyes, would no longer appear as solid flesh, but as a beautiful dance of organized emptiness, a place where the solid space has twisted itself into complex patterns that maintain their form while constantly exchanging their substance with the patterns around them. You'd see the air between your fingers not as nothing but as simpler patterns in the same solid medium, and you'd understand that the difference between your hand and the air is not the difference between something and nothing, but between complex and simple arrangements of the same fundamental solidity. Walking would feel different with this new perception. Each step wouldn't be a solid object moving through empty space, but a pattern propagating through a solid medium, like a wave moving across water. You'd feel yourself not pushing through nothingness, but gliding through somethingness. The solid space parting and reforming around you, supporting you, guiding your motion along the paths of least resistance. The sensation of movement would be like swimming through an invisible ocean, one that offers no resistance to your pattern, but absolute support for your existence. Breathing would take on new meaning. The air entering your lungs wouldn't be empty space filling with gas molecules, but patterns in solid space reorganizing themselves. The simpler patterns we call oxygen, joining with the complex patterns of your blood, not through empty spaces, but through the continuous solid medium that connects everything. Each breath would be an exchange of patterns, a trading of arrangements in the solid substrate, your body maintaining its form while constantly renewing its substance. In this inverted universe, the sensation of touch would be understood differently. When you touch the table, you wouldn't be feeling solid matter, meeting solid matter, but patterns in solid space, encountering other patterns, their wave functions overlapping, the quantum mechanical rules that govern how patterns can interact, creating the sensation of contact. The hardness of the table would come not from solid particles, but from the stability of the patterns, the resistance to reorganization, like touching a standing wave that maintains its form despite being made of motion. Light would reveal its true nature as waves in the solid medium of space itself. The sun's rays streaming through your window wouldn't be particles or waves traveling through emptiness, but ripples in the solid substrate, vibrations in the continuous medium that fills everything. Colors would be different frequencies of vibration in this solid space, and your eyes would be patterns organized to resonate with these vibrations, to decode the information carried by the waves in the solid ocean of space. Sound would make perfect sense in this inverted universe. The music playing in your room, the voices of loved ones, the ambient noise of life, all would be understood as compression waves in the patterns of solid space, not needing air as a medium because the solid space itself is the ultimate medium, capable of carrying vibrations at many scales and frequencies. The difference between sound and light would be merely the type of wave, the way the solid space vibrates, not a fundamental difference in what carries the waves. Gravity would no longer be mysterious. The earth beneath your feet wouldn't be pulling you down through empty space, but curving the solid space around it, creating a depression in the continuous medium that your pattern naturally follows. You'd understand your weight not as a force, but as the pressure of curved solid space, the way the universe's solid substrate guides patterns towards centers of curvature. Falling would be following the natural paths through curved solid space, and standing still would be resisting these paths, feeling the solid space press against you. In this solid space universe, distance would take on new meaning. The space between you and distant stars wouldn't be empty void to be crossed, but solid continuity to be traversed. The stars wouldn't be isolated islands of matter in nothingness, but special places where the solid space has organized itself into patterns of fusion and light. The vast distances wouldn't represent emptiness but fullness, enormous volumes of solid space in simpler configurations, waiting to be traversed by patterns of matter or waves of light. Time itself might be understood as a property of how patterns can change in solid space. The flow of time would be the rate at which patterns can reorganize, the speed at which information can propagate through the solid medium. The speed of light wouldn't be an arbitrary limit, but the maximum rate at which the solid space can transmit changes, like the speed of sound in a material. Your experience of time would be your pattern's evolution through the solid space, each moment a new configuration, each memory a record of previous arrangements. Eating and metabolism would be revealed as pattern transformation in solid space. The food you consume wouldn't be solid matter being broken down and absorbed, but complex patterns being simplified and reorganized, their arrangements becoming part of your arrangement. The energy released wouldn't come from breaking chemical bonds between atoms, but from patterns settling into lower energy configurations in the solid space. Your body wouldn't be building itself from matter, but organizing patterns in the solid substrate into the beautiful complexity of life. Sleep and dreams might take on new significance in this solid space universe. Sleep could be understood as a time when your pattern simplifies, when the complex arrangements that maintain consciousness relax into simpler configurations. Dreams might be your pattern, exploring different possible arrangements, trying on different configurations in the solid space without fully committing to them. Waking up would be your pattern reorganizing into its full complexity, the solid space remembering your configuration and rebuilding it each morning. Death, in this universe, wouldn't be the destruction of solid matter, but the dissolution of a pattern in solid space. The atoms of your body wouldn't disappear, but would simply reorganize into simpler patterns, the complex arrangement that was you spreading out into the simpler arrangements of earth and air. It might be less frightening to think of death this way, not as becoming nothing but as returning to a simpler pattern in the eternal solid space, your complexity dissolving back into the substrate from which it arose. But let's think about what society and civilization might be like if we truly understood space as solid and matter as pattern. Our technology might develop along entirely different lines. Instead of thinking about moving solid objects through empty space, we might focus on propagating patterns through solid space. Transportation might be less about vehicles and more about pattern transmission, finding ways to efficiently propagate human patterns through the solid substrate. Communication would be understood as pattern interaction in solid space. When you speak to someone, you're not sending sound through empty air, but creating pattern waves in the solid substrate that reorganize the patterns in their ears and brain. The internet wouldn't be signals traveling through empty space, but pattern propagation through the electromagnetic aspects of solid space. Every communication would be the solid space itself carrying patterns from one organized region to another. Medicine might focus on pattern correction rather than physical intervention. Disease wouldn't be solid pathogens invading solid bodies, but disruptive patterns interfering with healthy patterns. Treatment might involve helping patterns return to their stable, healthy configurations. Surgery wouldn't be cutting solid flesh, but reorganizing patterns in solid space. Healing would be the natural tendency of patterns to return to stable configurations, guided by the information encoded in DNA, itself a pattern in solid space. Architecture and engineering would work with the solid space rather than against it. Buildings wouldn't. Be solid structures standing in empty space but organized patterns in solid space, shaped to work with the natural flows and currents of the substrate. We might discover ways to curve solid space locally, creating structures that seem impossible by conventional physics. Cities might be designed as harmonious patterns in solid space, minimizing disruption to the natural patterns of the substrate. Art and music would be revealed as pattern creation in solid space. A painting wouldn't be pigment on canvas, but organized patterns of light interaction in solid space. Music wouldn't be sound waves through air, but organized compression patterns in the solid substrate. Dance would be human patterns moving through solid space in aesthetically pleasing ways. All art would be understood as the creation of beautiful, meaningful, moving patterns in the continuous solid medium that connects artist to audience. Science would focus on understanding the rules that govern pattern formation and interaction in solid space. Physics wouldn't be about particles and forces, but about how the solid substrate can organize itself, what patterns are stable, how patterns interact and transform. Chemistry would be the study of how atomic patterns combine into molecular patterns. Biology would examine how patterns can become self-organizing, self-reproducing, self-aware. Philosophy and spirituality might find new ground in this solid space universe. The connection between all things wouldn't be mystical but literal. Everything is patterns in the same solid substrate. Consciousness might be understood as a particular kind of pattern organization in solid space, not separate from the physical but a special arrangement of it. The universe knowing itself might be literal, the solid space organizing itself into patterns capable of perceiving and understanding the very substrate they're made of. Environmental concerns would shift focus. Pollution wouldn't be solid matter in the wrong place, but disruptive patterns in solid space. Climate change would be understood as changes in the large-scale patterns of Earth's atmospheric and oceanic arrangements in solid space. Conservation would focus on maintaining healthy, stable patterns rather than preserving solid matter. We might develop a deeper appreciation for the pattern complexity of ecosystems, seeing them as intricate, interconnected arrangements in solid space that took billions of years to evolve. Space exploration would be reimagined. Instead of sending solid objects through empty space, we'd understand ourselves as propagating patterns through solid space. The challenge wouldn't be crossing emptiness, but navigating the currents and structures of the solid substrate between stars. We might discover ways to ride the waves in solid space, to use the natural patterns and flows of the substrate to travel vast distances. The dream of reaching the stars would be the dream of extending human patterns through the continuous solid space that connects us to them. Quantum mechanics would make intuitive sense in this solid space universe. Superposition wouldn't be a particle being in multiple places at once, but a pattern spread out through solid space, not yet localized. Entanglement wouldn't be spooky action at a distance, but two aspects of the same pattern in solid space, naturally correlated because they're part of the same arrangement. Wave-particle duality wouldn't be paradoxical, but natural. Patterns in solid space can behave as waves when spread out and as particles when localized. The origin of the universe might be understood differently. The Big Bang wouldn't be matter exploding into empty space, but solid space itself beginning to pattern itself, perhaps transitioning from a simpler, higher energy configuration to the complex, structured arrangement we see today. The expansion of the universe wouldn't be stuff moving apart, but the solid space itself growing, creating more of itself, perhaps driven by its own internal dynamics. Black holes would be understood as places where the solid space has curved so extremely that patterns cannot escape, where the substrate itself has formed a kind of knot that traps any pattern that enters. The event horizon wouldn't be a surface, but a region where the paths through solid space all lead inward. The singularity at the center might be where our understanding of patterns in solid space breaks down, where the substrate itself might transition to a different state. Dark matter might be explained as variations in the density or tension of solid space itself, regions where the substrate is thicker or thinner, creating gravitational effects without visible patterns we recognize as matter. Dark energy might be an intrinsic property of solid space, a tendency to expand and create more of itself. The cosmic web of galaxies might be following the natural patterns of the solid substrate, like dew forming on a spider's web, matter patterns condensing along the natural structures of solid space. In this universe turned inside out, the fundamental questions would shift. Instead of asking, why is there something rather than nothing, we'd ask, why does the solid space pattern itself? Instead of wondering how consciousness emerges from matter, we'd wonder how patterns in solid space become self-aware. Instead of seeking the fundamental particles, we'd seek the fundamental rules that govern pattern formation in the solid substrate. Your daily experience would be transformed by this perspective. Waking up wouldn't be a solid body rising from a solid bed, but a pattern reconstituting its full complexity in solid space. Walking to work wouldn't be moving through empty space, but propagating your pattern through the solid substrate, riding the Earth's pattern as it rotates through solid space. Interactions with others wouldn't be solid bodies meeting, but patterns in solid space exchanging information, influencing each other's configurations. Even emotions might be understood as pattern states in solid space. Joy might be a particular harmonious arrangement of the patterns in your brain and body. Sadness might be a different configuration, one that feels heavy because it literally involves different curvatures in your local solid space. Love might be patterns resonating with each other, finding harmonious ways to interact in the solid substrate. Fear might be patterns preparing for rapid reconfiguration, ready to propagate quickly through solid space if needed. Memory would be patterns in solid space that persist, configurations in your brain that can recreate previous configurations. Learning would be developing new stable patterns, new ways for the solid space in your brain to organize itself. Creativity might be exploring new pattern possibilities, finding novel arrangements in solid space that no one has discovered before. Intelligence might be the ability to efficiently reorganize patterns, to find optimal configurations in the solid substrate. As night falls in this inverted universe, you'd understand darkness not as the absence of light, but as the solid space vibrating at frequencies your eyes can't detect. The stars wouldn't be distant suns shining across empty space, but patterns of fusion creating waves in the solid substrate that propagate to your eyes. The darkness between stars wouldn't be void, but solid space in its ground state. Quiet but never empty, always ready to carry waves, always connecting everything to everything else. And as you drift towards sleep in this solid space universe, you might feel a deep comfort in knowing that you're not a small, isolated bit of matter in a vast emptiness, but a beautiful, complex pattern in a completely full, completely connected solid substrate. The space around you, within you, isn't empty but solid in the deepest sense, supporting your pattern, maintaining your existence, connecting you to every other pattern in the universe through the continuous medium of space itself. Now we arrive at perhaps the most profound implications of our inverted universe, where the philosophical and spiritual dimensions of existence are gently reimagined through the lens of solid space and hollow matter. What does it mean to be human, to be conscious, to exist at all, if we are not solid beings in empty space but patterns of organized emptiness in a solid plenum? These questions don't demand urgent answers but invite slow contemplation, the kind of deep wondering that naturally leads toward peaceful sleep while opening the mind to new ways of understanding our place in the cosmic order. Let's begin with the question of identity, that most basic puzzle of who and what we are. In the conventional view, you are a collection of atoms, solid matter temporarily organized into the pattern of a human being. But we've seen that atoms are mostly empty space, and even the particles within them might be nothing more than excitations in quantum fields. If matter is hollow and space is solid, then you are not a thing but a process, not a solid entity but a persistent pattern in the solid substrate of space itself. This isn't just wordplay or philosophical speculation, but a direct consequence of what physics tells us about the nature of matter and space. Every atom in your body is mostly empty, and the parts that aren't empty are themselves made of particles that might be nothing more than knots, or waves, in quantum fields. The fields themselves are properties of space, not separate from it, but aspects of it. So you are, quite literally, made of space. Organized, patterned, complex arrangements of space, but space nonetheless. Consider what this means for the continuity of your identity over time. The atoms in your body are constantly being replaced. The food you eat becomes part of you, while parts of you are exhaled, excreted, shed. Scientists estimate that about 98% of your atoms are replaced every year. In what sense, then, are you the same person you were a year ago? If you're solid matter, this is a puzzle. But if you're a pattern in solid space, it makes perfect sense. The pattern persists even as the substrate flows through it, like a whirlpool that maintains its form while constantly exchanging its water. Your memories, your personality, your consciousness, all of these might be understood as aspects of the pattern, stable configurations in the solid space that makes up your brain. When you remember something, you're not retrieving solid information stored in solid matter, but recreating a pattern, rebuilding a configuration in solid space that resonates with a previous configuration. Your thoughts are not electrical signals jumping between solid neurons, but waves propagating through patterns in solid space, reorganizing the substrate in meaningful ways. This pattern view of identity has profound implications for how we understand life and death. If you are a pattern rather than a thing, then death is not the destruction of something solid, but the dissolution of a pattern. The solid space that organized itself into you doesn't disappear, it simply reorganizes into other patterns. In a very real sense, nothing is lost except the organization, the particular arrangement that was you. The substrate remains, eternal and unchanging, ready to form new patterns, new identities, new forms of existence. But what makes your pattern special? What distinguishes the organized emptiness that is you from the organized emptiness of a rock or a star or empty air? Perhaps it's the complexity of the pattern, the depth of its organization, the way it maintains itself while interacting with other patterns. Life might be defined not as solid matter exhibiting certain behaviors, but as patterns in solid space that can maintain and replicate themselves, that can grow in complexity, that can eventually become aware of themselves as patterns. Consciousness, that greatest of mysteries, might be understood as what happens when a pattern in solid space becomes complex enough to model itself, to create within its own organization a representation of its own pattern. Your brain, with its billions of neurons and trillions of connections, might be a pattern complex enough to contain a model of itself, and this self-model might be what we experience as consciousness. You're not just a pattern in solid space, but a pattern that knows it's a pattern, that can contemplate its own existence. This raises fascinating questions about the nature of experience itself. When you see the color red or taste sweetness or feel joy, what's happening? In the solid space view, these experiences might be particular modes of pattern vibration, specific ways the solid substrate can be organized that we interpret as qualia, as the felt qualities of experience. The redness of red isn't a property of light waves or neurons, but a particular pattern resonance in solid space that we've evolved to recognize and respond to. Free will, that perennial philosophical puzzle, takes on new dimensions in a solid space universe. If you're a pattern in a solid substrate that follows physical laws, are your choices determined? Perhaps, but the pattern that is you is so complex, influenced by so many factors, sensitive to quantum uncertainties at the smallest scales, that your behavior might be effectively free even if technically determined. Or perhaps free will emerges from the pattern's ability to model different futures and choose between them, to use its organization in solid space to influence its own future organization. The relationship between mind and matter, between consciousness and physical reality, has puzzled philosophers for centuries. But if matter is hollow and space is solid, if everything is patterns in the same substrate, then mind and matter are not separate categories but different aspects of the same thing. Your thoughts and your brain are both patterns in solid space, just described at different levels. The mental and the physical are not two different substances, but two ways of describing patterns in the one substance that exists, the solid plenum of space itself. This view resonates with many spiritual and philosophical traditions that have intuited the unity of all existence. The Hindu concept of Brahman, the ground of all being from which everything emerges and to which everything returns, sounds remarkably like solid space from which all patterns arise. The Buddhist concept of emptiness, shunyata, which doesn't mean nothingness but the absence of independent existence, aligns with the idea that all things are patterns in the same substrate, with no separate permanent essence. The Taoist concept of the Tao, the way or the flow that underlies all existence, might be understood as the dynamics of solid space, the rules that govern how patterns form and interact. The Western philosophical tradition of idealism, which sees reality as fundamentally mental or experiential rather than material, might find support in the idea that what we call matter is just organized emptiness, patterns of void in a solid plenum that might itself be more like mind than matter. But we don't need to invoke ancient wisdom to find meaning in this view. The solid space perspective offers its own profound insights into the nature of existence and our place in it. If everything is patterns in the same solid substrate, then we are literally connected to everything else in the universe. Not metaphorically, not spiritually, but physically actually, through the continuous medium of solid space. The atoms in your body, the air you breathe, the stars you see, the empty space between, it's all the same substance, just patterned differently. This connection isn't passive but active. Every pattern influences the space around it, creating fields, waves, disturbances that propagate through the solid substrate. Your gravitational field, tiny as it is, extends throughout the universe, weakening with distance but never reaching zero. The electromagnetic fields of your brain and heart extend beyond your body, interacting with the fields of others. In a solid space universe, we're all constantly touching, constantly influencing each other through the medium that connects us. The ecological implications are profound. If everything is patterns in the same solid substrate, then the environment isn't separate from us but continuous with us. Pollution isn't putting bad stuff into empty space, but disrupting the patterns of solid space in ways that interfere with life patterns. Climate change isn't just warming empty air but reorganizing the patterns of solid space in ways that might destabilize the configurations we depend on. Environmental protection becomes not about preserving things, but about maintaining healthy patterns in our shared solid substrate. Ethics and morality might be grounded in this understanding of our fundamental connection. If we're all patterns in the same solid space, then harming others is literally harming the same substrate that supports us. Helping others is helping the whole, contributing to the health and complexity of the total pattern. Compassion isn't just a nice feeling, but a recognition of our shared substance, our mutual arising from and dependence on the same solid space. The meaning of life itself might be found in this view. If the universe is solid space organizing itself into ever more complex patterns, then life might be understood as the universe becoming aware of itself, developing the ability to observe and understand its own nature. We're not separate from the universe looking at it from outside, but the universe looking at itself from within. Every moment of consciousness is the solid space knowing itself through the patterns it has become. Creativity takes on cosmic significance in this view. When you create something, a work of art, a new idea, a solution to a problem, you're not just arranging matter in empty space, but discovering new ways the solid substrate can pattern itself. Every creative act is the universe exploring its own possibilities, finding new configurations, new ways to be. Artists and scientists, musicians and mathematicians are all engaged in the same fundamental activity, revealing the pattern possibilities inherent in solid space. Love, that most powerful of human experiences, might be understood as pattern resonance in solid space. When you love someone, your patterns harmonize, finding ways to interact that enhance both patterns, that create something greater than either alone. The feeling of connection isn't illusion, but recognition of the literal truth. You're connected through the solid space that you both are patterns in. The boundaries between self and other are not walls, but arbitrary distinctions in a continuous medium. Even suffering and evil can be understood through this lens, though not explained away or justified. Suffering might be pattern disruption, configurations in solid space that are unstable or conflicting. Evil might be patterns that destroy other patterns, that decrease the complexity and beauty of the whole. But because everything is patterns in the same substrate, suffering affects the whole, and the dissolution of harmful patterns might ultimately lead to healthier configurations. The question of why there is something rather than nothing transforms in this view. If space is solid and eternal, then there has always been something, the solid substrate itself. The question becomes not why something exists, but why the something patterns itself, why the solid space organizes into the complex forms we see. Perhaps pattern formation is simply what solid space does, as natural and inevitable as water flowing downhill. Or perhaps there's a deeper principle, a tendency toward complexity, toward self-awareness, built into the nature of the substrate itself. The arrow of time, the fact that we remember the past but not the future, might be related to how patterns can form in solid space. Perhaps the solid substrate has a built-in directionality, a tendency for patterns to become more complex, more organized, at least locally and temporarily. The flow of time might be the flow of pattern formation, the direction in which the solid space naturally organizes itself. We remember the past because those patterns have already formed in solid space, but we can't remember the future because those patterns haven't organized yet. The possibility of other universes, other realities, takes on new meaning. If our universe is patterns in solid space, organized according to certain rules, might there be other regions of solid space organized according to different rules? Or might the same solid space be capable of supporting multiple overlapping pattern systems, invisible to each other like different frequency broadcasts in the same electromagnetic spectrum? We might be one of many pattern systems. In an infinite solid plenum, each universe a different way the substrate can organize itself. As we contemplate these philosophical implications, notice how they don't diminish the meaning or value of existence but enhance it. You're not a tiny, temporary, isolated speck in a vast emptiness, but a unique and precious pattern in an eternal, continuous fullness. Your consciousness is not a random accident, but the universe knowing itself through you. Your relationships are not mere proximity of separate beings, but the interweaving of patterns in a shared substrate. Your creative acts are not arbitrary arrangements, but discoveries of the possible. Death loses some of its sting in this view, though not its poignancy. If you are a pattern in solid space, then death is not annihilation but transformation. The pattern that was you will dissolve, yes, and that particular configuration may never repeat. But the substrate remains. The solid space that held your pattern continues, perhaps retaining some trace, some influence of what you were, and the complexity you contributed, the patterns you created or influenced, the ways you changed the configuration of solid space around you. These ripple outward, affecting patterns you'll never know about. Purpose and meaning emerge naturally from this understanding. If the universe is solid space, organizing itself into ever more complex and aware patterns, then our purpose might be to contribute to this complexification, to add our unique pattern to the whole, to help the universe know itself more fully. Every moment of awareness, every act of kindness, every creation of beauty, every discovery of truth is the universe understanding and expressing itself through us. The search for truth, for understanding, becomes not about discovering external facts, but about the universe coming to know itself. Science is the solid space developing patterns capable of understanding pattern formation. Philosophy is patterns contemplating their own nature. Art is patterns exploring the aesthetic possibilities of pattern. All human endeavor is the universe examining itself from within, using us as instruments of self-discovery. As you lie there, drifting towards sleep, you might feel a deep peace in this understanding. You're not alone in empty space, but held in solid fullness. You're not separate from the universe, but an expression of it. You're not meaningless, but meaningful by your very existence, as a pattern capable of contemplating meaning. The solid space that patterns itself as you also patterns itself as everything else. And in this shared substrate we find our deepest connection, our truest home. The void that is full, the matter that is hollow, these are not just abstract concepts, but lived realities that we experience every moment without recognizing them. Every breath is an exchange of patterns in solid space. Every thought is a wave through the solid substrate. Every emotion is a configuration of the continuous medium. We are hollow in the sense that we're mostly organized emptiness, but we're full in the sense that we're patterns in the solid plenum that underlies everything. This philosophical journey through the implications of solid space and hollow matter doesn't provide final answers but opens new questions, new ways of wondering about the nature of existence. And perhaps that's the point, not to solve the mystery but to deepen it, to find ever more beautiful ways to contemplate the puzzle of being. The universe doesn't demand that we understand it completely, but invites us to participate in its self-discovery, to be the patterns through which it comes to know itself. And now, as our journey through the night approaches its end, we return to where we began, to that soft question whispered in the darkness. What if empty space was solid and matter was empty? But we return with new eyes, new understanding, carrying with us all the wonders we've discovered along the way. The question hasn't been answered so much as deepened, transformed from a simple inversion of assumed reality into a profound meditation on the nature of existence itself. Let's gather all the threads we've woven through this night and see what tapestry they form, what gentle secret the void has been whispering to us all along. We began in your room, in the immediate space around you, with the familiar feeling of solid matter and empty air. But even there, in that most ordinary of spaces, we found the first hints that things are not as they seem. The air that seems empty presses against you with the weight of miles of atmosphere. The solid walls are mostly empty space between atoms. The distinction between something and nothing, between full and empty, began to blur even in the most familiar environment. Then we expanded our view to the cosmic scale, from your room to the edge of the observable universe, and found that at every scale, what appears empty is never truly empty. The space in your room contains air molecules, electromagnetic fields, gravitational influences. The space between planets contains solar wind, magnetic fields, cosmic rays. The space between stars contains interstellar medium, diffuse gas, dark matter. The space between galaxies contains the cosmic web, dark energy, gravitational waves. At every scale, the void reveals itself to be full, structured, active. We dove into the quantum realm and discovered that even the most perfect vacuum we can create trembles with zero-point energy, seethes with virtual particles, vibrates with quantum fields. The vacuum is not the absence of everything, but the presence of all fields at their lowest energy state, ready to be excited into what we call particles. Empty space has pressure, can be polarized, carries the Higgs field that gives particles their mass. The nothing is so much something that it determines the very nature of matter itself. Looking at matter, we found it to be mostly empty space. Atoms are vast voids, with tiny nuclei and distant electrons. Even the particles themselves might be nothing more than excitations in quantum fields, knots in the fabric of space itself. Your solid body is 9% empty space, and the tiny fraction that isn't empty in the conventional sense is itself made of point particles with no classical size, surrounded by clouds of virtual particles. Matter is not the opposite of empty space, but a special organization of it. Einstein's revelation that space and time are woven together into space-time, and that this space-time can bend, stretch, and ripple, showed us that the void has geometry, structure, dynamics. Gravitational waves are ripples in emptiness itself. Black holes are places where emptiness curves so extremely it traps everything, even light. The expansion of the universe is empty space creating more of itself. The void is not passive but active, not static but dynamic, not nothing but very much something. Our spacecraft, those brave mechanical explorers, have ventured into what we call the void and found it full of phenomena. Voyager discovered the complex boundary where solar wind meets interstellar medium. Cassini found unexpected particles in the gaps of Saturn's rings. Parker Solar Probe revealed magnetic switchbacks in the solar wind. Every mission sent to explore emptiness has found it full of structure, activity, substance. The void speaks to those who know how to listen, and it never says nothing. We imagined living in a universe where this understanding is complete, where we perceive space as solid and matter as pattern. Walking becomes pattern propagation through a solid medium. Breathing becomes pattern exchange in continuous substrate. Touch becomes pattern interaction in quantum fields. Everything we experience is reframed not as solid things in empty space, but as patterns in solid space, temporary organizations of an eternal substrate. The philosophical implications transformed our understanding of identity, consciousness, meaning itself. If we are patterns in solid space rather than solid matter in empty space, then we are processes, not things, verbs, not nouns, temporary organizations of an eternal substrate. Consciousness might be what happens when patterns become complex enough to model themselves. Death is not destruction, but pattern dissolution. We are literally connected to everything through the continuous solid space that we're all patterns in. And now, having travelled this great circle from the familiar to the cosmic and back again, what have we learned? Not a final answer, but a deeper question. Not a solution, but a more beautiful mystery. The void whispers its gentle secret, that emptiness and fullness are not opposites but perspectives, that matter and space are not separate but continuous, that something and nothing are not contradictory but complementary aspects of a single, unified reality. Perhaps the deepest secret is that the question itself, what if empty space was solid and matter was empty, is not hypothetical, but might be the actual nature of reality, hidden from us only by the limitations of our perception and the habits of our thought. Physics keeps pushing us toward this view. Quantum field theory tells us particles are excitations in fields that fill all space. General relativity tells us space itself has geometric properties, can curve and wave. Quantum mechanics tells us matter is mostly empty and behaves like waves in a medium. Every deep investigation into the nature of reality points toward the same conclusion. The void is full, matter is pattern, everything is connected through a continuous substrate. But why does this matter? Why spend a night contemplating such abstract ideas? Because this understanding, even if held lightly, even if only entertained as possibility, changes everything about how we experience existence. If you are a pattern in solid space, then you're not small and insignificant in a vast emptiness, but a unique and precious organization of the fundamental substrate of reality. If everything is connected through continuous solid space, then you're never alone, never isolated, always part of the whole. The fear of emptiness, the void that has terrified humans throughout history, loses its power when we understand that there is no void, no true emptiness anywhere. Even the darkest, most distant reaches of intergalactic space are full of fields, energy, potential. The universe is not mostly nothing with rare spots of something but completely full, with what we call matter being just places where the fullness is organized in particular ways. You exist not in spite of the void, but because of it, supported by it, made of it. This view brings a deep peace, a cosmic comfort. You are held, always, by the solid substrate of space itself. Every atom of your being is supported by quantum fluctuations in the vacuum. Every thought you think propagates through fields that fill all space. Every breath you take is an exchange with the fullness that surrounds and permeates you. You cannot fall out of the universe because you are the universe, organized temporarily into the pattern that experiences itself as you. The journey we've taken tonight, from your room to the edge of existence and back, has been like those Russian dolls, each containing another, except every doll we've opened has revealed not a smaller doll, but a larger universe. The room contains the cosmic, the atom contains the infinite, the void contains everything, and you, lying there, contain it all. Not physically, but conceptually, able to contemplate scales from the quantum to the cosmic, able to wonder about the nature of existence itself. As we've explored this inverted universe where space is solid and matter is empty, we've been doing what humans have always done, trying to understand our place in the cosmos, trying to find meaning in existence, trying to glimpse the truth behind appearances. But unlike our ancestors who had only their senses and their imagination, we have the accumulated observations of science, the mathematical frameworks of physics, the data from spacecraft and telescopes and particle accelerators. And all of it points toward this strange, beautiful, inverted truth. The solid space idea is not just philosophy or speculation, but where physics seems to be leading us. String theory suggests that particles might be vibrations in higher dimensional space. Loop quantum gravity suggests that space itself might be quantized, made of discrete units. Quantum field theory already treats particles as excitations in fields that fill all space. Different approaches, different mathematics, but convergent implications. Space is not nothing but something. Matter is not fundamental but emergent. Everything is connected through a continuous substrate. But even if future physics overturns this view, even if we discover that space and matter are something else entirely, the journey we've taken tonight remains valuable. We've learned to question our assumptions, to see the familiar as strange, to find wonder in the ordinary. We've discovered that the universe is far more mysterious, far more interconnected, far more beautiful than our everyday experience suggests. We've found that even the most basic concepts, space, matter, emptiness, solidity, are not what they seem. The void's gentle secret is not just about the nature of physical reality, but about the nature of knowledge itself. Every answer opens new questions. Every discovery reveals new mysteries. The more we learn about the universe, the stranger and more wonderful it becomes. The void we thought was empty turns out to be full, but full of what? The matter we thought was solid turns out to be pattern, but pattern in what? Each level of understanding is not a final truth, but a doorway to deeper mystery. And perhaps this is the real gift of our contemplation tonight. Not certainty, but wonder. Not answers, but better questions. Not knowledge, but awe. The universe doesn't demand that we understand it completely. It invites us to explore, to wonder, to discover. It reveals itself slowly, in glimpses and hints, always holding more in reserve, always deeper than we can fathom. The void whispers its secrets to those who listen, but it always keeps some secrets for tomorrow, for the next generation, for the endless future of discovery. As you drift towards sleep, carrying with you the images and ideas we've explored, remember that you are part of this cosmic mystery. The same questions that puzzle cosmologists about the universe apply to you. What are you? Pattern or substance? Where do you end and the world begins? How does consciousness arise from matter, or from pattern, or from whatever we ultimately discover reality to be made of? You're not separate from the mystery, but part of it. Not observing from outside, but wondering from within. The comfort in this understanding is not the comfort of knowing, but the comfort of belonging. You belong to the universe not as a possession, but as an expression. You are the universe contemplating itself, wondering about its own nature, discovering its own possibilities. Every thought you think is the cosmos thinking. Every feeling you feel is the cosmos feeling. Every dream you dream is the cosmos dreaming. You're not in the universe, you're the universe, temporarily organized into the pattern that calls itself you. And what of tomorrow, when you wake from the sleep that's gently approaching? Will the world look different? Will space seem solid and matter seem empty? Probably not in any obvious way. The illusion of solid matter and empty space is too useful, too ingrained, too necessary for navigating daily life. But perhaps, in quiet moments, you'll remember. When you feel the weight of your body, you might recall that it's the curvature of space-time you're feeling. When you see the stars, you might remember that the space between you and them is not empty but full. When you touch someone you love, you might know that your patterns in the same substrate, temporarily organized into separate forms but fundamentally continuous. The question we've explored tonight, what if empty space was solid and matter was empty, doesn't need a definitive answer. Its value is not in being resolved, but in being contemplated. It's a koan, a puzzle that opens the mind rather than closing it. It's a doorway to wonder, an invitation to see the familiar as strange, the ordinary as miraculous. It reminds us that reality is not what it seems, that our perceptions are limited, that the universe is far more mysterious than we usually acknowledge. As this night's journey comes to its close, we return to silence, to stillness, to the quiet darkness that surrounds you. But now you know that the silence is not silent but filled with vibrations below the threshold of hearing. The stillness is not still but trembling with quantum fluctuations. The darkness is not dark but glowing with cosmic background radiation. And the space around you is not empty but solid in the deepest sense, supporting you, connecting you, making your existence possible. The void has whispered its gentle secret. It is not void but plenum, not absence but presence. Not nothing but everything. And you, dear listener, are not a small, separate, temporary thing, but a beautiful, unique, precious pattern in the eternal fullness of space itself. You are the universe knowing itself, the cosmos dreaming itself. The void discovering it was never empty at all. Sleep now, held by the solid sky, supported by the substantial void, connected to everything through the continuous medium of space itself. Let your thoughts dissolve into simpler patterns. Let your consciousness relax into the substrate that supports it. Let yourself return to the fundamental piece of being, pattern in plenum, temporary organization in eternal fullness. The questions will remain. When you wake, always deepening, always beautiful, always leading you deeper into wonder. The void's gentle secret is that there is no void, only fullness appearing as emptiness, only solid space organizing itself into the temporary patterns we call matter and life and consciousness. You are that organization, that pattern, that place where the universe has arranged itself into awareness. And in the quiet darkness, as sleep approaches, you can feel it, the solid space that you're made of, that supports you, that connects you to everything, whispering its eternal secret. You are home, you have always been home, you are the home itself, temporarily dreaming it is separate, eternally waking to its unity. What if empty space was solid and matter was empty? The question fades now into peaceful wonder, into the approaching embrace of sleep, where all questions dissolve into the fundamental mystery of being. The journey through the night is ending where it began, in your room, in your body, in the immediate experience of existence. But you return transformed, carrying the knowledge that the room, the body, the existence itself is far stranger, far more wonderful, far more connected than you ever imagined. Rest now in this understanding. Float in the solid space that holds you. Dream in the patterns that you are. And know, with the deep knowing that comes at the edge of sleep, that you're exactly where you belong, in the fullness that appears as emptiness, in the everything that masquerades as nothing, in the eternal solid sky that we call, in our beautiful ignorance, the void.